Well, hello and welcome you to Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. I messed up my gestures, that's okay. Step on inside, and we're going to work on section 3.5 of the Big Ideas Math Integrated Math 2 textbook, where we graph out of factored form. Some teachers will call it intercept form, and for a great reason, and factored form for a great reason. They're both the same thing. I tend to call it factored form. I believe the book calls it factored form, so we'll go off that. I think there are 80 problems this time. I think that's the number that I typed, so sit tight as we do the lecture and try it out. We'll see how long this thing goes. Timestamp down below, graph paper down below, description section. We'll also show a playlist down below, and yeah, let's go ahead and get going. Let's see if my Braves cannot get eliminated from the playoffs. How about that? That would be very splendid. Let's actually look at the math. That's just some fun interactivity while we're working. We're going to learn to graph quadratic functions of the form f of x equals a times x minus p times x minus q. We've seen something of this variety. This looks like a factorization of something. I don't know if they have us factor or not. I assume they do. Excuse me. And then we'll see what to do with that. We're going to use intercept. Oh, they do call it intercept form. Never mind. If I call it factored form. Use intercept form to find zeros of functions, and that's kind of part of the graphing portion of it. Use characteristics to graph and write quadratic functions. Okay, great. Here we go. So, excuse me. Oh, my bad. Graphing f of x equals a times x minus p times x minus q. You've already graphed quadratic functions written in different forms. We've used standard form here. We've used vertex form here. Now we're going to use, I was wrong, they call it intercept form. If I call it factored form, that's just by nature of this is factored. But intercept form is used for a reason. In terms of when you have it factored, because this can get you the x-intercepts of the graph very easily. If you have this form factored in the x minus p times x minus q, your x-intercepts are p and q. The reason for this, doesn't look like they're really saying it, the reason for this is because when y is 0, you can use the zero product property and say if this times this equals 0, either this equals 0, that equals 0, and then you solve using that zero product property. We did that a lot in chapter 2. So it's that same setup. We can automatically set it up like that and kind of solve. Maybe I'll do it once over, or they'll show you that. But those are intercepts. What's cool about these intercepts is they're not only points on the graph, but they are corresponding points on the graph. They are the same height, which means they're the same distance away from the axis of symmetry. The axis of symmetry is exactly halfway between your two intercepts. So if it's factorable, right, they're going to give you problems that are factorable. If it's factorable, we got a couple intercepts there. If we got our intercepts, then we find that halfway distance between these two things so we can get the axis of symmetry. Now, there are a couple ways you can do this. We can use it on the graph by kind of counting half the distance. That's totally fine. But they're going to give you kind of a formula version. P plus Q over 2. Why do they give you P plus Q over 2? Because this is averaging. This is averaging your two values. The midpoint of two numbers is the average of them. And how do you average something? You add them and divide by 2. So why is the axis of symmetry important? Because we still need to find the vertex. The parabola's vertex will be on the axis of symmetry. So we find the x-intercepts. We then find the axis of symmetry exactly halfway between. We use that to find the vertex and plot any other points that we can after that. Perfect. Okay. So we're going to look at some examples here. They start by graphing f of x equals negative x plus 1 times x minus 5. Describe the domain and range. It's already in factored form. It has your factors with linear factors with x here, so we can solve. Your a is out in front. A is negative 1. We'll get to that. But your x-intercepts are going to be negative 1 and 5, essentially the opposite of these numbers here. It's what number gets you 0. That's the important part. So negative 1 and 5. So we plot negative 1, 0, and 5, 0. Now exactly halfway between negative 1 and positive 5, you can count that. The distance between these two is 6, so half that distance is 3. 3 away from negative 1 and 3 away from 5 is 2. X equals 2 is your axis of symmetry. Now they averaged your values. Well, I'll do both. It depends on what we have. But if you're starting to make the graph, you can also count that distance. So halfway between is x equals 2. If you substitute 2 into your equation, remember your factored form equation, then you will find the y value for your vertex. The vertex is on that axis of symmetry. Plug in 2 into here. Negative, the opposite of 2 plus 1 times 2 minus 5 apparently gets you 9. And when I write it out, I'll show the in-between step because there's a little pattern that happens here, kind of the same way that a pattern happened out of standard form. I have a little bit of a cough. I'm going to clear my throat here. Give me 1 second. Okay, we'll see how that panned out. So we graphed that based on that. Now, the only points they showed us were this one and these two. I'm going to plot points in between, such as the stretch factor is negative 1. So you can do that 1, 1 and 2, 4 and things like that. Now, we're in factored form, so it doesn't show you y-intercepts, but we can look at things like expanding to standard form, and you'll confirm that your y-intercept's indeed there. I really want to convert between forms at some point in total and really show you how they all show up. Anyway, domain and range. Domain is all real numbers. Expect that for pretty much all these problems that aren't word problems. Range is y is less than or equal to 9. 9's your maximum here for the y value, and we go down from there. You can definitely see it from the graph. Let's look at another example where you have f of x equals 2x squared minus 8. This time it's not factored. Now, this is in standard form, which means we can, this is your ax squared plus bx. There's no bx here, but plus c. Your c is negative 8, which also means it's your y-intercept. If you want a point on the graph, we got one, and it just so happens it looks like it's the vertex as well. We don't know that yet, or actually we might because it's ax squared plus c. But we need to find also those x-intercepts, and we want to find it out of factored form. So let's factor this. We start with the GCF, and the GCF is now so important here because that'll represent the a value. Anything that can factor out before you do the other factoring. You factor out a 2, and then you have a difference of 2 squares here, so we can factor that down, x plus 2 times x minus 2. Negative 2 and 2 are going to be your 2. I'm not going to say p equals with them. I'm just going to find your x-intercepts when I do it. But negative 2 and 2 are both your x-intercepts. Halfway between negative 2 and 2 is 0. So your axis of symmetry is on x equals 0, vertical line on the y-axis. You plug in 0 into your equation. They did it in the standard form one. I'm just going to do it in the factored form one when I do it later. But 2 times 0 squared minus 8 is negative 8. So you get 0, negative 8 there. So your y-intercept is also your vertex. Pretty cool. So it looks like we get to factor out of standard form, which means more practice on that. I'm not going to slow down on those ones, clearly. I have 80 problems to do, but there's that. We have a couple more to show you, a couple factored forms and standard form, and we go ahead and factor. I hope not all of them are just factoring difference of 2 squares, though. I hope they let us kind of play with it more. They say find the zeros. Now, the zeros are the same thing. I guess they're separating the problems. The zeros are, and we talked about this back in chapter... It might have been chapter 1 even. Chapter 1, if not chapter 2. It might have been 1. Finding the zeros is setting y equal to 0. They're showing that here. Set y equal to 0 and solve for x. This is y. Again, these are the x-intercepts. When y equals 0, what are the values of x? And they didn't really bring that up before, and that's what that is. What values of x give you 0 for y? Those are also your x-intercepts. So they found out that negative 2 and positive 1 are your 2 zeros of your function. Zeros and x-intercepts get to be used interchangeably as terms. They do. That's what we do with them. And that's kind of what they're saying here. For any factor, x minus n. N is the 0 because if x minus n equals 0, then x equals n. I guess that's what they want to go with. So right here, they're kind of helping you skip some steps. When you set that equal to 0, x plus 4 equals 0, so x is negative 4. They probably should have showed this back in chapter 2, right? Just skipping some steps. You swap the signs. If x plus 4, then x is negative 4. If x minus 4, then x is positive 4. That's what they're getting at. Now, you can't get there until you're factored, right? So they show you factor, GCF of negative 2. Boom. Factor this guy into x plus 3 times x plus 2. Boom. What are the zeros? Negative 3 and negative 2. Boom. Negative 3 and negative 2. Zeros here are 6 and 1. Factor, factor, and go to town. Okay, good. The examples get to go really fast because it's things we've seen before, or at least you've seen if you've done it with me or if you've done it with your teacher. Using characteristics to graph and write quadratic functions. So let's use the zeros to graph h of x equals x squared minus 2x minus 3. I mean, it's still going to be the same thing as before. This is going to be the same thing. They say use the zeros. The zeros are the x-intercepts. So honestly, I see no change in these problems, just a different word. We still factor it. If you set it equal to 0, then you get negative 1 and positive 3 as your x-intercepts. Those are those points. So that doesn't change. They're just kind of interchanging the terminology. Now, notice another point that they showed you, and I talked about it on the last example that we graphed. Negative 3, that's your y-intercept. And notice the y-intercept this time is not necessarily the vertex, but use that point. Because not only is that one point on the graph, but when you get your x-intercepts and you figure out your axis of symmetry in the middle, then that means that you can reflect this point across as well. You get more points for yourself. That's not the vertex, but you get more points for yourself without needing to use that stretch factor yet. Of course, I'm going to plot as many points as I can fit. You know me with that. So I'm going to keep going with that. They just say draw a parabola through. I'm going to plot as many points as I can fit. Write a quadratic function in standard form whose graph satisfies the given condition. So they say standard form here. So we are actually, let's see how they go through this problem. They are, okay, it depends on what they're giving you on the problem, because in these situations, there's more than one way to do these, but they're going to ask you to base it off a different form to get there. On part A, problem A, they say the vertex is negative 3, 4. They say write a quadratic function. It's open-ended. You're allowed to kind of choose something that you want to do here for your a value. But this is your h and this is your k, negative 3 and 4 in this vertex form equation. So we substitute negative 3 in for h. You get x plus 3 squared, and k is 4, so plus 4. Notice they just chose 1 for a. You can choose any number as long as it's not 0. You can choose 2, you can choose negative 3, 1/2, things like that. Depends on how much you want to do. Then they expand this. They expand this x plus 3 squared is x squared plus 6x plus 9, and plus 4 is x squared plus 6x plus 13. Grandissimo. So standard form is taking vertex form and doing that. I guess they want to, just like on the vertex form, I think last section in vertex form, we had even and odd functions as well. It had nothing to do with vertex form. It was just a place they wanted to fit it. So they're fitting this here because now you've seen all the different forms, and because the next section doesn't have to do with factored form. Part B says let's pass through negative 9, 0, negative 2, 0, and negative 4, 20. Well, negative 9, 0, negative 2, 0 can work as your x-intercepts. X-intercept of negative 9 and of negative 2. That means in factored form, if negative 9 is an x-intercept, x plus 9 is a factor. And if negative 2 is an x-intercept, then x plus 2 is a factor. Now, this one in particular, this will be one very specific equation because they give us a third point, negative 420, which means this is some other xy value, which will help identify what our a is. This time, we don't choose the a. They kind of force us to find what it is. So we substitute negative 4 for x right here, and 20 for y right here, and then we kind of solve for that a there. Negative 4 plus 9 is 5, negative 4 plus 2 is negative 2, 5 times negative 2 is negative 10, 20 equals negative 10a, divide by negative 10, and a is negative 2. So your equation in standard form, we still have factored form here. Your equation in factored form is this, negative 2 times x plus 9 times x plus 2, and then you expand things out. You start by foiling this out. We're going to do these in problems together, and then we distribute the negative 2 afterward. Foil first, distribute second. That's kind of just a general, if we factor in that direction, then we should foil opposite direction, right? And they have a check for the graph. I'm all good. Okay, more examples for us. I think we're good to go. I'm just going to skip ahead and move on. Okay, and they go to our vocab core and core concept check. So, about 12 minutes there. Pretty good on time. Let's go ahead and try some of these. The values p and q are blank of the graph of the function here. They represent x-intercepts of f of x equals a times x minus p times x minus q. P and q. When you set that equal to 0, boom, we're there. Explain how to find the max or min value of a quadratic function when the function is given intercept form. Okay, there's not much room for me to write on here. I'll just go ahead and type this thing out. The max or min, keep in mind, the max or min is the vertex. If the y value of the vertex is the y value of the vertex. To find it, we must locate the x-intercepts of p and q. I'll just say p and q. Find the axis of symmetry. Let's see how to... I might have to sneeze. Find the axis... Excuse me. Find the axis of symmetry by averaging your x-intercepts values and substitute that x value into equation to find y. Now, it is a maximum. It is a max if a is less than 0, and it is a min if a is greater than 0. Remember, if a is positive, the parabola faces upward. And if the parabola faces upward, then that means that... Let me face the camera. If the parabola faces upward, then that means that the vertex is on the bottom, so that would be a minimum. If the parabola faces downward, then we're at a maximum, because that's the top of it. Okay, guys, so we're going to go and do the problem set here. Now, we have numbers 3 through 80 to do, so it seems like quite a bit, unless I don't have to do too many graphs, which I'll probably have to do some. If I don't have to do too many graphs, hopefully we can get through some of it pretty well, especially if we can kind of cut corners. They're really talking about zeros being x-intercepts, the same thing. I'm going to really say, if we set y equal to 0, here's what's going to happen on them, right? So that's going to kind of be our goal. So let's go ahead and get started here. We're going to start with problems 3 through 6. 3 and 4 have graphs. 5 and 6 do not. They are asking us to, get the right pen, find the x-intercepts and axis of symmetry of the graph of the function. They're not asking us to graph, clearly, because 3 and 4 already have graphs. But the equation is y equals x minus 1 times x plus 3. Now, the first ones, I think, I can't even write. The first ones, I think, They give us the graph so we can confirm that we know what we're doing correctly. I still want to do this based on the numbers, not by looking at the graph. And then we'll look at the graph to confirm it. So looking at the numbers here, if y equaled 0, then you would get x-intercepts of 1 and -3. So that's that part. And I can confirm that on this graph here. That looks like that is 1 and -3. Now, there are two ways you can find this axis of symmetry. You can, at this point, if you started graphing it, you can find half the distance between -3 and 1, which would be x equals -1 right there. But if we were to calculate it, and we didn't have the graph, because I'm not going to have the graph on 5 and 6, you might know half that distance. But otherwise, for the axis of symmetry, it's going to be x equals, and you average those numbers, 1 plus -3 divided by 2. And that's -2 over 2, which is -1. So it's x equals -1. Make sure you write that, because I really didn't. X equals -1, AOS. There we go. All right, I'll clean up the next problem. Sorry about that. It's been kind of a long day. Number 4. We have -2 times x minus 2 times x minus 5. They just want axis of symmetry, right? Okay. Y equals -2 times x minus 2 times x minus 5. So the x-intercepts, once again, are going to be the opposites of what you see in this factored form. They're going to be 2 and 5, and you can confirm that on the graph right there. Looks like 1, 2, 3, 4, 5. This axis of symmetry, what's the number between 2 and 5? Looks like to go right down the middle there. Looks like it's going to be 3.5, and you probably know that it is. If you're uncertain on that, let's go ahead and average the numbers 2 and 5. For the axis of symmetry, we're going to get x equals 2 plus 5 all over 2, which is 7 over 2, which is 3.5. So x equals 3.5 is your axis of symmetry. Number 5, this time we do not have the graphs to confirm what we're doing, and I'm not intending to graph them, not until they're asking us to do so. So number 5, let's just rely on our numbers. F of x equals -5 times x plus 7 times x minus 5. Now, the x-intercepts will be -7 and +5 based on taking those opposites there, -7, +5. And what's the number halfway between those two? I believe it's -1. Let's go ahead and take a look at that and average those two numbers. Axis of symmetry is going to be x equals -7 plus 5 over 2, which is -2 over 2, which is indeed -1. And again, the purpose of the axis of symmetry is so we can find the vertex in full. That's the x value of the vertex, and plug that into the equation to find the y value. Not for these problems, but for probably the next set. Number 6, we have g of x, especially if we had to graph it. G of x equals 2/3 times x plus 8. Now notice how I said 2/3 times x, etc., right? This is one of your factors, not the 2/3. That's like your a value. But x is one of your factors. What's the opposite of x? We don't take the opposite of x. We take the opposite of what's adding or subtracting with x, which is 0. The opposite of 0 is -0. Well, it's 0, right? We say we set this equal to 0, either this times this equals 0. Either x equals 0, right? That's an x-intercept here. If you plug 0 into there, we'll get 0 out. That's what we want. Or if I substitute -8 for x, then we will also get 0 out as well. So that is a 0 and a -8. So don't say -2/3, don't say -x, nothing like that. Those are your x-intercepts. And we should also know that halfway between 0 and -8 is -4. So axis of symmetry there, make no two bones about it, x is -4. Let me pause one more second here. Sorry, I really wanted to look at the Braves game situation. They have 3 more outs to go if they can get 3 outs here, and otherwise they're facing elimination. All right, numbers 7 through 12. We are going to graph these quadratic functions. So I'm going to have my graph paper with me. I'm going to use the tall ones just in case. We're going to label the vertex, axis of symmetry, and x-intercepts. Describe the domain and range of the function. So a lot of things to do, but that all comes with the territory of a graph. Okay. So on number 7. We have f of x equals, in factored form, x plus 4 times x minus 1, or x plus 1. Therefore, we do have x-intercepts. I'm going to find those first. We have x-intercepts of -4 and -1. I'm going to begin by plotting those. So -4 and -1. Now, the axis of symmetry would be exactly halfway between here. And if you're, not good at counting that, I'm going to draw where it is. You can see the symmetry. But if you're not good at counting or finding where that thing is, we can average it one more time. I think for the most part, if I have the visual, guys, I'm just going to go ahead and use that. But for this one, let's start axis of symmetry. We're going to have x equals -4 plus -1 over 2, which is -5 over 2, which is -2.5. So x equals -2.5, axis of symmetry. Now we're going to find, I mean, we have to graph it. They say label, they say label those things, but we got to find them. We got to find the vertex now. So let's do the y value, f of negative 2.5. Substitute that in for x in this form here. Negative 2.5 plus 4 times negative 2.5 plus 1. That's going to be 1.5 times negative 1.5, which is negative 2.25 if I know my math there. So negative 2.25. So your whole vertex is going to be at negative 2.5, comma, negative 2.25. So not my favorite one to get other points out from because it's kind of a quarter basis here, but 2.25 right there. And it crosses through there. They'd probably just say graph it and you're done. I happen to know it's also going to cross at 4 at some point as well, because when I expand that out, plus 4 would be at the end. But if I got some other points here, I can go 1, 1, 2, 4, 1, 2, 3, 4. It's kind of hard to count on these parts here, though. 3 and 4, 5, 6, 7, 8, 9. Like I said, I'm someone who plots as many points as you can fit. Oh, by the way, if this is a point, then this is also a corresponding point over here. Let's get at least one more. 1, 2, 3, 4, and 16 up from negative 14. It's going to be right there. Is that right? 1, 2, 3, 4, 5, 6, 7. No, it's not right. 1 down from there. That looks a little tall. Did I just do the same thing? 1, no, 3, 4, 5, 6. Okay, good. So I'm going to reflect across there. All right. So those are points of this graph here. They probably would have gotten you significantly less, but that's okay. And there's the parabola. They said label them. I'm just going to point to where they are based on what I found on the things here. So I have an axis of symmetry right here. I have a vertex right here. And what else? X-intercepts right there. I hope I didn't ruin my graph by doing that. I kind of did. Skinny it out. There we go. All right, those are your points. That's your stuff. Okay, number 8. Oh, let's do the next page. Number 8, y equals x minus 2 times x plus 2. Okay. X-intercepts. X-intercepts are at 2 and negative 2. So I can begin with these guys right here. I don't think I have a faster way to go about labeling these afterward. I don't know how I want to go about doing that. I'll probably save it at the end. Axis of symmetry should be right in between there. So axis of symmetry, literally between negative 2 and 2 is 0. So I'm going to go ahead and just draw that right there. It's x equals 0. So on the y-axis, so that's x equals 0. On 0, if you substitute 0 into here, we can then find the vertex y value. So vertex y equals 0 minus 2 times 0 plus 2. It's also the y-intercept. So this is going to be negative 2 times 2, which is negative 4. So your vertex is at 0, negative 4. So it's right there. The stretch factor is 1. I don't know if I mentioned that last time. The stretch factor was 1. So we're going to be able to go 1, 1. 2, 4 is already there. 3, 9. Over 4 up 16. And whoops, and that's all I can probably fit right there. Okay. So let's point at those other parts there. We're going to get vertex right there. That's pretty thin, you can't see that. Vertex right there, and then axis of symmetry right there. They said label it, so I don't know if that works out for you guys, if you're okay with it. They probably want you to do it on the graph. I think from now on I'm going to do it on the graph. The arrow thing gets a little weird. Sorry about that. Okay, number 9. Still in factored form. Looks like we're going to stay in factored form for this whole set. So we got y equals negative x plus 6 times x minus 4. Let's begin with the x-intercepts. This time I'm going to label them when I hit the graph. So our x-intercepts will be -6 and +4. So I'm going to hit those right now. X equals -6, x equals +4. So x-intercept of -6, 0, and then 4, 0. Okay. The axis of symmetry is right in between. These are 10 apart from each other. So 5 apart from each other is at -1 right there. That's where you're going to have your axis of symmetry. So that is x equals -1. Boom. I'm going to substitute -1 into this equation to find the y value of the vertex. So we're going to get the opposite of -1 plus 6 times -1 minus 4. And that is the opposite of 5 times -5, which is positive 25. This graph does go upside down, so it makes sense that it's going to be up high. Now that's higher than I can actually reach for even my tall graph, unless I go, say, by 2's. So I guess I'm going to go ahead and go by 2's here. So this is going to be 10 and 20 and 30, like that. So 25 will be right in the middle of 20 and 30, right there. And then I'll just have to be careful when I do some of my stretch stuff. Obviously, they're probably going to put as many points as us. I know that 24 is actually the y-intercept right there. Here's my 1, 1 basis, over 1, down 1. So hopefully you understand my stretch. That's -5 and +5 still. The vertex is at -1, 25 right there. Pretty tough on the labeling crowd, right? So over 2, down 4, like that. Over 3, down 9, 2, 4, 6, 8, like that. Oh, it's right there. And let me get at least one more. Over 4, down 16. So 2, 4, 6, 8, 10, 12, 14, 16. And then that's, I guess, 25 down from that last one is over 5 like there. So I think that's going to be enough for me, especially because the scale gets a little wonky. The labeling gets a little tough. Sorry about that. I really just got to find a good way to label for you guys. Can't think of it. If I label on the side, is it okay? I just do that on the side? I think I might want to just start doing that now because it's otherwise it just gets way in the way here for us. Number 10. I think it's their last shot. Number 10. H of x equals -4 times x minus 7 times x minus 3. Okay. Yeah, I'm just going to label on the side. X-intercepts are 7 and 3. Sorry, I improvise when doing these things, as you can tell. I'm trying to figure out how to best do that. So 7 and 3 here. Halfway between 7 and 3 is 5. Your axis of symmetry is at x equals 5. About right there. Okay. So there's labeling. For the vertex, your y value, h of, we're going to substitute 5 into there. And we're going to get -4 times 5 minus 7 times 5 minus 3. So that's going to be -4 times -2 times +2. That's -4 times -4, which is 16. So your vertex is at 5, 16, which I can fit on my graph. So I'm going to box those. So that's my labeling. I hope that's okay. So 16 is way up here. My stretch factor is -4, so I'm going to get some points for you guys. I'm going to go ahead and go over 1, down 4. When we go over 2, we go down 4 times 4, which is down 16. That's why we hit those points right there. When we go over 3, we would go down 36. I can't fit 36 away from here, so that's honestly as many as I can fit. I'm going to go ahead and just do that. My y-intercept is way out of reach. My y-intercept is -84, if you can believe that. -84. I cannot fit that on this graph. Not even close. Come on, Braves. Now, before I move forward, I want to point out something. Did you guys notice this? Well, every time I substitute the x value of the vertex into factored form, I get -2 times 2. I get -5 times -5. I get -2 times 2. I get 1.5 times -1.5. What's happening is you're getting opposites of each other. Now, I'm not saying you can predict what they're going to be, but I'm saying that if you don't get opposites of each other by substituting those in, something went wrong. That will always happen for your vertex x value when you plug it into factored form. If you remember, standard form had something similar like that, right? We would do like 8, then -16 was -8, and like we'd have that. Same kind of effect. Something strange happens on this one too, and that's what that one is. All right, number 11, g of x equals 5 times x plus 1 times x plus 2. Ooh. So your x-intercepts are -1 and -2. So those are pretty close together, right? -1 and -2. Axis of symmetry fits right in between those. That's at -1.5. If you average -1, -2, that is what you get right there. Whoop. That always glitches over. Right there. So axis of symmetry, AOS, x equals -1.5. Let's substitute that into there for the vertex. We're going to get g of -1.5. We're going to have 5 times, and check this out, these should be opposites. -1.5 plus 1 times -1.5 plus 2. This will be 5 times, here we go, -0.5 times +0.5. That's half of 5. So -1.25, -1.25. Is that right? Yeah. I think so. -1.25. So your vertex is going to be at -1.5, -1.25. It should be pretty close to that. Okay. The stretch factor was 5 as well. So boom, and -1.25 down there. To get some other points for you, I do happen to know that your y-intercept is going to be at 10 because I'm doing 5 times 1 times 2. It's really all the last things, right? When I FOIL this thing out, 1 times 2 happens, and then I have to distribute 5 into that. That's how I'm getting some of those numbers. So that's a nice special sauce one without actually expanding with you guys, getting that 1. I can go over 1 up 5. It's hard to count them once they're actually not on points right here. I can count just fine otherwise, and I have trouble. Over 2 would have been up 5 times 4, up 20, and that probably just goes out of reach. -1, that goes just out of reach. It's probably somewhere about up there-ish, but it goes pretty stretched. I can reflect this point over, though. That's fine. All right, I got a couple points there. Very tall graph. And I got my labels on the side for my vertex, axis of symmetry, and my x-intercepts. It's not going to be the perfect curve, but I got a lot more points, and I like that. See, I wouldn't just want those 2 points in the vertex. They're way too close to be able, unless you're scaling inward, they're way too close to be able to confirm what kind of curve you're going to get. That was pretty tall. Number 12. Oh, I hope they didn't lose. I hope they switched pictures. Number 12. Y equals -2 times x minus 3 times x plus 4. X-intercept's farther apart this time, but we're still going to have some fraction issues. We get 3 and -4. So let's go ahead and plot those. So we get 3 and -4. Axis of symmetry exists halfway between these. Maybe I have trouble with that, but they're 7 apart, and half of 7 is 3.5. So 1, 2, 3.5. So at -0.5. X equals -0.5 is your axis of symmetry. Okay, the vertex y value. We're going to get y equals -2 times -0.5 minus 3 is -3.5. That must mean the other one must be 3.5, and it is -0.5 plus 4. I think that's -12.25 if I know my squares, and then times that is positive. Oh boy, that should be the easy part. Positive 24.5. That's going to be out of reach, so I believe it, but that's just going to be out of reach. That's not going to be an easy graph to do. All right, so vertex, I should use a calculator for that. Let me check that out. 3.5 times 3, whoops, 0.5 times 2. Yeah, 24.5. So, I'm trying to think how to change the scale, because if I go by 2s, I guess, but if I go by 2s, then it's like, how do I hit? All right, let's see. This is 10, 20, 30. So your vertex is at -0.5, comma 24.5, and that is 20. Here's 25 right there. So 24.5 is just gonna be kind of halfway between that and 20. So a quarter of the way. Okay, a quarter of the way like that. Not too many points I can get that are splendid. Even I got 24 as a y-intercept. That's not so far away from this, so it doesn't give me much character from there. If I go over 1, I go down 2, but down 2 is down 1 here because I'm stretching by 2s. So over 2, down 4, or down 8, 2, 4, 6, 8. Remember my vertical stretch factor is -2. So like that. Oh, what happened, Pilar? What'd you do? Over 3, down 18. So 2, 4, 6, 8, 10. I should be better at this. 12, 14, 16, 18, like that. And that's all I'm going to fit, because after that we get the x-intercepts, and that's pretty good. Okay, you get that falling effect there. Nice smooth curve to your x-intercepts. So I have them labeled and good to go. What's going on? Oh. Tying runs at first base. Okay, one more out to go. Number 13. 13 through 20. Graph the quadratic function, label the... Okay, same stuff. Oh, I didn't do domain and range of all the previous problems. Let's go back. Let's say this straight up, guys. Domain's all real numbers. Domain's all real numbers, right? So let's go back. Number 7. Excuse me, I really apologize. Domain, all real numbers. Range, it's going to be based on your vertex. Y is greater than or equal to negative 2.25. Okay? Sorry about that. Number 8. Domain, all real numbers. Range, y is greater than or equal to negative 4. Number 9. Domain, all real numbers. Range, y is less than or equal to 25. Number 10. Domain, all real numbers. I don't have much to say on these things. Range, y is less than or equal to 16. It goes downward, right? It's all about the min, max. I'm looking at these y values. I'm looking at the y. I'm looking at which way it faces. That's pretty much all I'm doing. And domain's all real numbers. Number 11. Domain, all real numbers. Range, y is greater than or equal to negative 1.25. And then 12. Domain, all real numbers. Range, y is less than or equal to 24.5. Grissom. Okay, so same thing on 13 through 20. The difference is they're not factored yet, so we have to factor first. The cool thing is, now I found y-intercepts using my own means the other time, but the cool thing is we can use standard form to identify the y-intercept clearly on the equation things. The problem is a lot of these y-intercepts would be out of my reach, so I'm not going to bother with the y-intercept and changing that stretch if the vertex fits within my thing just fine. So number 13, y equals x squared minus 9. Now this is a difference of two squares, so this does factor into x plus 3 times x minus 3. That's my factored form, or my intercept form, where I can get my intercepts out of. Now, keep in mind, negative 9 is the y-intercept, so I am going to go ahead and plot that. This is the y-intercept. I want that, so I'm going to plot that as a point. It exists. One more strike. Hold on. I'm going to keep this over here for me to see it. Okay, my x-intercepts are negative 3 and 3. So we are going to plot those here and here. Looks like the axis of symmetry is where the y-intercept is. It's at x equals 0, the y-axis. Boom. We're good. So axis of symmetry. I'll put these in blue so you can definitely see them once we hit the graph stuff. Axis of symmetry is x equals 0. And then the vertex, well, this is going to be the vertex, but let's kind of confirm that at that point. So we're going to get a vertex of, oh no, did the Phillies just win? We're going to get a vertex of y equals 0 plus 3 times 0 minus 3. Once again, we get one of those 3 times negative 3 things. 3 times negative 3. Yeah, I don't know what the Braves do in the postseason that make them terrible. Negative 9. So the vertex is going to be at 0, negative 9. And that's, we already have that point right there. So from here, besides domain and range, which I'll remember to do, is I got to use my stretch factor of 1 to get some more points here. So 1, 1, 2, 4. 3, 9 is right there. 4, comma 16 is right there. 5, comma 25 is up at 16 up over here. See, I like plotting as many points as I can fit when no fractions are a part of the deal. I'm going to do that just fine for you guys. I don't like drawing the curve, though. That's kind of hard to do with this. See? Sorry about that. Let's fix that a little bit. Okay. All right, your domain. All real numbers. Range. Y is greater than or equal to negative 9. Okay. Number 14. Now, this might take a while. I have 80 problems to do. I'm not even a fifth of the way done. Barely even a sixth. I'm not going to be a sixth of the way done. Number 14. F of x equals x squared minus 8x. Now this would be a plus 0 when it comes to your y-intercept. I know that I get to plot a point on the origin. That doesn't necessarily, well, it'll mean one thing. It'll mean that's one of your x-intercepts, but it doesn't necessarily mean anything regarding the vertex, but we definitely have a point there. Now, the greatest common factor here is x, right? We have a GCF of x, so we can factor that out, and we'll have x minus 8 here. That leaves you with x-intercepts of, that first one's going to be 0, right? X-intercept of 0 and 8. So I have 0 there, I have 8 here. My axis of symmetry should be right in between 0 and 8. Halfway between 0 and 8 is 4. So x equals 4 is the axis of symmetry. So we got that and that. I'm really disheartened about my Braves, man. Got x equals 4 right there. Let's substitute 4 into this equation. You can either do the factored form or the standard form. I'm going to stick with the factored form just because I earned it or whatever. It just, I don't know if it makes it easier or harder. But it doesn't make it either. We got 4 times 4 minus 8 is negative 4. Clearly, that's going to be that thing that we do, the opposites of, and that's negative 16. So your vertex is going to be at 4, negative 16. So we get to plot that guy way down here, and we have a stretch of 1. So I get to do my 1, 1, 2, 4, 3, 9, 4, 16 is as you see right there. One more I can fit in at least the x version is 5, 25. Which is going to be right there. I don't think I can fit 636, so I'm going to stop right there. Okay. Domain is all real numbers. Range is y is greater than or equal to negative 16. So domain, all real numbers. Range, y is greater than or equal to negative 16. Okay. Number 15. H of x equals negative 5x squared plus 5x. 15. H of x equals negative 5x squared plus 5x. So let's start with the GCF. It looks like negative 5x is that GCF. The negative 5 counts, or the negative counts for that. Negative 5x times x is negative 5x squared. Negative 5x times negative 1 is a positive 5x. So we get that. This is your a value, and this is one of your factors there. So treat it like a times that times that. So when it comes to your x-intercepts, we're looking at 0 as one of them for the same reasons as before, right? A plus 0. Y-intercept, it's also your x-intercept then. X-intercept of 0 and then of 1. So we're going to fit, ooh, it's going to be a tight fit. So halfway in between 0 and 1, we'll find the axis of symmetry, and we'll find the vertex as well. It should be slightly above, though, even with the stretch factor of 5. Let's plot that a little tighter. Okay, so there are the x-intercepts. Here's your axis of symmetry at 0.5. Let's substitute 0.5 into our equation. So, axis of symmetry, x equals 0.5. Let's find h of 0.5 in my vertex form. I'll get negative 5 times 0.5 times negative 0.5. That's 0.5 minus 1, right? 0.5 times negative 0.5. We had that number before, right? This was something? Half of 1.25? So 1.25 here. Last time it might have been negative. This time it's positive. So the vertex is going to be at 0.5, comma 1.25. There we go. So we got that, that, and that. And let's go ahead and plot that 0.5, comma 1.25 right there. 1.25. Let's get some more points out of this. We already have the y-intercept, so let's go over 1 down 1, 2, 3, 4, 5. And can I fit over 2 down 20? I think it's just like the last problem. Not really. It's probably just a little bit lower than all that, so I'll kind of give it its look. It's probably around there-ish. Close-esque. That's got to be reflected a little bit more. There. Okay. Within the ballpark of that, with a stretch factor of 5, negative 5, I should say. Be going pretty low, pretty sharp. Pretty sharp. There we go. Okay. Domain. Domain, all real numbers. Range. Y is less than or equal to 1.25. Number 16. we're going to have y equals 3x squared minus 48. Now that is not a y-intercept that I'm going to be able to fit if the scale is normal. I don't know if I can fit it if I scale it by 2s. So you're probably not going to see me hit that y-intercept. Okay. Well, I'll have to hit the y-intercept. It's going to be part of my vertex, so I might have to. Let's start by factoring 3 out, and I'll get x squared. I just dropped something. We'll get x squared minus 16. And then we get 3 times, this is the difference of 2 squares, factors to x minus 4 times x plus 4. Okay, so if that's the case, you have x-intercepts of 4 and negative 4. Now, this one is, yeah, I'm going to have to change my scales here for sure. That negative 48, guys, it's going to be your vertex. Because we have 4 and negative 4, right? The axis of symmetry exists between here. That vertical stretch makes this pretty tall. And those are kind of far apart from there. So your axis of symmetry is x equals 0, right in between 4 and negative 4. So we got those. We got to substitute 0 into here. You know what you're going to get out? I want to plug it into this one this time. Y equal, for the vertex, y equals 3 times 0 squared minus 48. Well, that's negative 48. So your vertex is at 0, negative 48. Now, when it comes to scaling, mine goes up to 17. Even if I tripled it, it'll fit. I just don't know how I want to fit other points on the graph. Oh, going by 3s, that might work. So if I do, every increment's going to be a 3. So this is negative 15, negative 30, and negative 45. Good. So I'm going to hit negative 48 right here. That's another 3 more down from there. Now, this is what's cool. My stretch factor is 3, so over 1 up 3 is just right here. So I can just treat it as 1, 1, 2, 4, because that's 2, 12. So 2, 4. Yeah, this will work out just fine. 3, 9, or slash 3, 27. Boom. And then 4, 16 is 4, 48. Boom, right there. So if I change the scale like that, I am all good. And then let's keep going. Let's get some other ones. 15... 30 and 45. It's the tallest graph on the planet. 75 up is 25 now, right? So 25 up from there, I think, is right here. I think that's all I can fit. So pretty tall. I mean, I compressed it by going by 3s, but I kind of had to. I don't have a graph tall enough to do that. At least, even if I did, you wouldn't be able to see it all on one screen. Pretty good looking graph, I do declare. Domain is all real numbers. Range is y is greater than or equal to negative 48. That is number 16. Only halfway through these guys right here. So I got a vertex there, domain and range right there. Oh boy, popping bottles. Number 17. Q of x equals x squared plus 9x plus 14. This time it's not about a GCF or anything or difference of 2 squares. This time we're going to have to figure out 2 numbers that multiply to 14 and add to 9. Well, that would be 7 and 2. So this can factor into x plus 7 times x plus 2, like so. That gives you, and 14 is your y-intercepts, by the way. I'm going to be able to plot that. This gives you x-intercepts of negative 7. My neck's bothering me. Negative 7 and negative 2. I have to get commentary on everything about me, man. This is what separates me from the robot people when they teach. They don't talk about their personal lives. My personal life, my back and neck bother me in this position. Negative 2 and negative 7. It's kind of the way that I maneuver things. Halfway between here, that's 5, and half that's 2.5. So 2.5 right there, that's negative 4.5. So hopefully you understand that count. If not, average your numbers. Negative 7 plus negative 2 is negative 9. Divided by 2 is negative 4.5. Your axis of symmetry is at x equals negative 4.5 right there. Right there. And negative 4.5 is what we are going to be able to substitute in to find our vertex, our y value for our vertex. Q of negative 4.5. Now you could use this right here. I think this will become a little cleaner for me. Negative 4.5 plus 7 times negative 4.5 plus 2. That'll be 2.5 times, what, negative 2.5? Which is negative 6.25. Negative 6.25. So you got a vertex of negative 4.5 comma negative 6.25. So that's 1, 2, 3, 4, 5, 6, 0.25, 6 and a quarter. We did get a y-intercept of 14. And it's not only that point that we get, but also the point that reflects across. That's 1, 2, 3, 4.5 away. 1, 2, 3, 4.5 away. Did I do that right? Yeah. That's a nice point. These are pretty good for a curve in and of itself. Stretch factor is 1. Over 1 up 1. Over 2 up 4. Is that right? 1, 2, 3. Yep. Over 3 up 9. I'm going to get one more. Over 4 up 16. So 10, 11, 12, 13, 14, 15, 16 right there and right there. Okay. With the x-intercepts and y-intercepts, I get even more consistency than I'd be able to get, which is always cool. If only I could actually go through the points when I'm actually drawing the curve. Gets a little tough to do, right? A little tough to do. All right. Domain. See, I haven't forgot domain and range yet, have I? Domain, all real numbers. Range, y is greater than or equal to negative 6.25. Okay. Number 18. I hope problems go faster after these ones. I know we're going to hit word problems and such. Or are we? Did we do? I'm sure we will. P of x. This one has opportunity for good word problems. That's what I'll say. X squared plus 6x minus 27, because those intercepts are helpful. Now we can solve with them. They let us. Factor. So 9 times negative 3. Whoopsie. 9 times negative 3 would give you negative 27, and 9 minus 3 would give you 6. So x plus 9 times x minus 3. Okay. Negative 27 is your y-intercept. I won't be able to fit that unless it pertains to the vertex, and I might have to. It looks like I might actually have to. I think the vertex is even taller than that, so you can bet I'm going to hit it. So x-intercepts of, let me erase that, of negative 9 and positive 3. Yeah, these are pretty far apart, which means this thing, it's not a 1/2 stretch factor or anything like that. This will be pretty tall. I mean, it's a normal stretch factor, but it's pretty separated from each other. Negative 9 and positive 3. Now, what's half that distance? Maybe this is the time where you average your numbers, right? So axis of symmetry, let's do this. Axis of symmetry, let's average them. I mean, I know the number, but that's okay. X equals negative 9 plus 3 over 2, which is negative 6 over 2, which is negative 3. So axis of symmetry is x equals negative 3. That's, boom, right there, the halfway mark between those two. We're going to substitute negative 3 into this. I'll use the factored form. So for vertex, the y value, p of negative 3. We're going to have negative 3 plus 9, which is 6. Negative 3 minus 3, which is negative 6. And that gives you negative 36. So for me to fit this, check this out. If I go by 2s, this is 17. 17 doubled is 34. It still wouldn't fit. I'm going to use it anyway. I'm going to double these. So I'm going to get myself negative 10, negative 20, negative 30. I'm just going to use it anyway. It's going to be down here. Boom. Vertex. All the way down there. The y-intercept is at negative 27. So 22, 24, 26, 27 is going to be right there. So I can reflect that across right here as well. Which, you know what? That's not... It's unfortunate because that's one of my... In my stretch factor things, I would have found that point anyway. But those are points, right? We can use those. We can go 1, 1. And remember, that's just halfway because they go by 2s. So 1, 1. 2, 4. Here's your 3, 9 right there. Remember, this is just 5 and negative 5. 4, 16 is the same as 4, 8. So 1, 2, 3, 4, 5, 6, 7. I miscounted that. 1, 2, 3, 4, 5, 6, 7, 8. 5, 25. So 8. 16. 18, 20, 22, 24, 25. And it looks like the x-intercepts are at the 636, right? 636. I'm going to stop it right there because I can't even really fit more on the left side. So that seems like enough. Okay, domain and range. Oh, I didn't even officially write the vertex yet. The vertex is at negative 3, comma, negative 36. Here's your axis of symmetry. Here's your x-intercepts. Your domain is all real numbers. Your range is y is greater than or equal to negative 36. We're almost an hour in. Or not even a quarter way through. Number 19. Ooh, this better not be a 4-hour video. I don't have enough space on my computer to record all that. Number 19, y equals 4x squared. If you can imagine, I'm going to go fast when I can. My speed here is relatively good, but I'm going to go fast when I can. Like this factoring. Start with a GCF. 4, x squared minus 9x plus 8. Boom. Factor, because this is last chapter stuff, right? X minus 8 times x minus 1. How'd you get that? This was last chapter stuff, right? So your x-intercepts are 8 and 1. Halfway between 8 and 1 should be 4.5. But let's let this decide for us, right? This is going to be very tall as well because the stretch factor is 4. So I'm going to have to change the scales on this, I'm sure, as well. So 8 and 1. Halfway between is right here. 4. X equals 4.5. Not like that. Let's fix that. Axis of symmetry. X equals 4.5. Let's find the vertex by substituting 4.5 into our equation. And yeah, I feel much more comfortable plugging into the factored form. I don't want to square 4.5 and times 4. That's quite a bit. That seems egregious. But this number is going to be big. 4 times 4.5 minus 8 is negative 3.5. And 4.5 minus 1 is positive 3.5. Now, you know, another thing, these numbers are the distances between the x-intercepts and the thing, right? Clearly. So if you found out these are 7 apart, half the distance is 3.5, that's what those numbers are. Those are the distances from there. So you might have gotten them early on, which is cool. That's 12.25. 49? Negative 49? Is that right? I'm going to go with it. I think it's negative 49. So your vertex is at 4.5, comma, negative 49. Yeah, the last one was 24.5 when we doubled it. So there's that. Domain, listen, I'll tell you straight up, domain's all real numbers. Range is y is greater than or equal to negative 49. That's going to be the lowest, the minimum. How do I scale this now? I can still kind of go by 3. Well, let's go by 4. So this thing has a stretch factor of 4. Let's go by that. So we can get 1, 2, 3, 4. So negative 20, negative 40, and negative 60 like that, where this is going to be like 5 and negative 5. So here, negative 49 is, so if they go by 4s, 48, 44, 48, 49 is a quarter way from there. Now, every time I go over 1 up 1, that's really over 1 up 4, which is cool because that goes with my stretch factor. So my 1, 1 is actually a point that's on here because we're going to stretch by 4. By the way, our y-intercept is 32. So remember, this is 20. Wow, this goes pretty tall pretty fast, huh? This is 20, 40. So 32 is 24, 20, 32 right here. So it's going to hit that. That means it's also going to reflect across and hit that. So we got our y-intercept use. So 1, 1, 2, or 1, 4, 2, 16, which is me counting up 4, 2, 16, 3, 9, 5, 6, 7, 8, 9. Let's get the 4, 16 point. So kind of like that. Now, what are those actual values? This actual value is 16, 15. So 15, y equals 15. So like that. I'm going to stop it right there. That looks good. Looks accurate. Looks smooth. I got my intercepts. I got my axis of symmetry. Got my vertex. And I said intercepts, not just the x ones, but the y ones as well. I got my domain. I got my range. I am set, folks. I am set. That is number 19. Number 20. Yeah, about 4 minutes of problem there. Number 20. Y equals negative 2, x squared, minus 4x plus 30. Let's factor. We got a negative 2 GCF. So we got x squared plus 2x minus 15. Two numbers that multiply to negative 15 and add to 2 are 5 and negative 3. This is once again going to be tall. That's the thing that's hurting us most, these tall graphs. And it's just, I made tall ones, but not tall enough, apparently. We have x-intercepts of negative 5 and 3. Let's go and plot those ones. With the stretch factor 2, you can get them better. I'm going to have to change the scales again. I might be able to go by 2s, which would be nice. This graph will go upside down. So negative 5 and 3. So check this out. Here's a good reason to talk about half that distance once again. Between negative 5 and 3 is a distance of 8. Half that distance is 4. So you know what? Like, I'm going to say this right now when it comes to the calculation of the vertex. I mean, here's the x equals -1 is your axis of symmetry, right? But here's what I'm going to be multiplying here to get my vertex. First of all, axis of symmetry, x equals -1. For my vertex, I'm going to be multiplying this -2 out here by that 4 and -4. Those are, when I plug -1 into here, -1 plus 5 is 4, -1 minus 3 is -4. I can go straight into that if I really understand that that 4 and -4 are half that distance that we do with. So -2 times that distance times that distance. Just make sure you know that the signs are opposite. Anyway, that'll be 32, right? It's going to be up above. So you got a vertex of -1, comma 32, like that. So we got this, we got this, we got... I shouldn't have said v equals. This is going to be y equals for v. So for the vertex, y equals like that. Okay. -1, comma 32. If I go by 2's, it will work out. So I can get, 2, 4, 6, 8, 10, 46, 20, and 30. And so 32 is going to be right there. So that'll fit every time I go by 2's, right? This is over 1 down 2. So that works. And that's the y-intercept of 30. That seems to work out, right? That's your 30. Over 2, down 1, 2, 3, 4. That's technically down 8, but that works out. Over 3, down 18, which is, I'm just going to count 9, 5, 6, 7, 8, 9. And that over 4, down 16 is going to hit that guy. Let's do one more. Over 5, down the 25 from there. It's going to be all the way, I think, down here. Okay. And that might be the last graph we do for a while, or it might just be the beginning. I'm not sure. But that is number 20. Let's get the domain and range, and then get out of that. Okay, domain. All real numbers. Range. Y is less than or equal to 32. Going down from 32. Awesome. Okay, let's go to 21 to 28. Find the zeros of the function. This should go relatively fast. They don't ask us to do anything, but basically once we factor this thing, unless it's already factored, once we factor it, we are just kind of doing the opposites. It's the same thing as the x-intercepts. Let's just call them x equals that, right? It's literally, like, work-wise, what I should be doing is, like, setting y equal to 0. I'll do it for the first one, but after that, I think we cool, man, we cool. So -2 times x minus 2 times x minus 10. When they do say find the zeros, they mean solve for this one, y equals 0. That's what makes those x-intercepts, right? Set that equal to 0. Either x minus 2 equals 0, so x equals 2. Same stuff as your x-intercepts, right? Or x minus 10 equals 0, so x equals 10. So I'm going to skip a lot of the mumbo-jumbo, literally, for a lot of problems. For my time and your time, I'm going to copy down the problem. If you see that it's factored, then your opposites of these values will represent the answer, because you don't have to divide by something with the x or anything like that. It's already set to go. These are the kind of easy problems once you recognize what you're being asked to do. And I know if, like, my students had this, they'd say, so wait, just take the opposite? Well, yeah, but why? Why are we taking the opposite? Your zeros are going to be -5 and 1. Why are we taking the opposite? Because we turn y into 0. This is factored. We use zero product property. Set x plus 5 equals 0. That means x is -5. So like that, right? There's a reason. So it's not so just do this. It's not a process. It's an understanding. And the process is just do that. But it's an understanding. Let's understand it. Number 23, this is not set equal to, it's not factored. X squared minus 4. You factor it first. This factors into x plus 2 times x minus 2. Now we can find those zeros, set that equal to 0. Zero product property, you're going to get -2 and +2 as your zeros there. Again, they represent the x-intercepts as well for this graph. There's no difference in those names. Another difference of two squares in number 24. So we got h of x equals x squared minus 36. This is where I get my speed, right? H of x factored is x minus 6. Let's hope they all go like this the rest of the way. Times x plus 6. I'm not even like, not that much done. So x equals 6 or -6 there as your zeros. Okay, let's go on to, there's still 4 more within this set. So number 25. More to factor though. They're going to get deeper into factoring. Notice that it's not the complex factoring, as in there may be a GCF on times, but then you're still left with a 1x squared, because they want to make sure that if we're graphing these zeros are nice, they're clean. Yeah, and that's what we got here. So this factors into x plus 8 times x minus 3. 8 times -3 is that. 8 minus 3 is that. And that's what we're going for. So the zeros are -8 and +3. Looks good. Number 26. Just moving on up, guys. Sorry. Not sorry. We slowed down. I mean, the problems were slow. That's what they were. Y equals x squared minus 17x plus 52. I don't factor 52 much. That's 13 times 4. I know that. So negative, yeah. So this can be x minus 13 times x minus 4. That's one of the first. They don't use 13 very often within factors, and this is going to be one of those times, it looks like. 13, and you know what? I couldn't fit that on a normal graph when I do my, I would have had to stretch my x's out. But 13 and 4 are going to be your zeros for 26. Number 27, we do have a GCF this time. We're going to factor a 3 out of here. You can anticipate that we're building off of these. See, the first two are factored form. The second two are difference of two squares. The next two were a 1x squared factoring, and the next ones are get a GCF out first, and then do 1x squared factorings. They build on each other. They're going by difficulty standards. So let's begin by factoring that 3 out. We get 3 times x squared minus 5x minus 14. That is 3 times x minus 7 times x plus 2. So we factor first. Your x-intercepts, your x-intercepts are 7 and, your zeros, Your zeros are x equals 7 and x equals negative 2. And then number 28, we're going to do g of x equals negative 4x squared. I sense a GCF of a negative coming. I see where this is going even further. This one, they're not going to ask you to graph this one just yet for reasons. Let me show you. You're factoring negative 4 out. You get x squared plus 2x plus 1. Now, this is a perfect square trinomial. I'm not sure if you're aware of the fact. This is x plus 1 times x plus 1, or x plus 1 squared. There's only one 0 here. The 0 in this case is x equals negative 1. It has a multiplicity of 2. What happens is this is your only x-intercept. They'll probably ask this later, I'm sure, because they start to expand and say critical thinking. How can a quadratic, a U-shape, that seems to be passing the x-axis twice, I can see how it might not pass at all. How can it only pass once? If this is also the point of your vertex. So the way that happens is if it does something like that. That's what we're looking at right there for that problem. So I might have given away a secret that they're going to tell you later. But all I was saying was, what stinks about this is your x-intercept is your axis of symmetry is also the point for your vertex all at the same time. You don't get extra points on top of it. You have to find all the extra points. Thankfully, this should have gone upside down. But thankfully, the y-intercept would be one of them. So this would have gone upside down. This would have went like this here. So the y-intercept would be a point you can reflect across and kind of do that stuff. But that's your x-intercept and vertex. Anyway, I might have given away some secrets. Let's move on to numbers 29 to 34. Match the function with its graph. So I'm going to write some things down, I guess. Because it's about pulling out information and then finding the match, right? I don't want to just match. I mean, how do you match? You find information. So what's my information? Positive 1 stretch, it goes upward. X-intercepts, or zeros of negative 5 and negative 3. So let's find those ones. We can get other points with that, but where do we hit negative 5 and negative 3? Yeah. I think right here, right? Negative 5, negative 3. I'm going to take that stretch of 1 for as it is. At least it's positive, so it looks like it's going to be D. It's going to be day. So graph D works out for 29. Number 30. They all have 5s and 3s. So really, the important thing, and some have duplicates of 5s, some duplicates of 3s. The important thing for you in this case is to kind of weed out what they are. And they're all positive, so that doesn't really help us. So x plus 5 times x minus 3. These x-intercepts are negative 5 and positive 3. I wrote that wrong. Are negative 5 and positive 3. So let's find that. The problem is some of these scales, right? I see a negative 5 here, because these go by 2s, so that's negative 5, and that's positive 5. So it's not that. That's negative 3 and positive 5. I think it's this one. Negative 5, positive 3. Notice how these go by 2s. The only one that went by 1s, E goes by 1s. B, D, and E go by 1s. The rest, the other 3 go by 2s when they have to spread out. So negative 5 and positive 3, that is graph F. I should really write out what those things are and just match it from there. I go the hard route. I assume you have a textbook that you can't write in, so you probably can't do the same thing. All right, number 31. Now it's positive 5 and negative 3, right? Take a look at this one. X minus 5 times x plus 3. At least the problems go relatively fast. X-intercepts of 5 and negative 3. Let's see. Opposite signs. So right here, 5 and negative 3. Looks like C. Let's graph C. Number 32. Y equals x minus 5 times x minus 3. Take the opposites of those. You get 5 and 3, right? So x-intercepts of 5 and 3. So they're both on the right side. So 5 and 3. I think it's B right here. 3, 5, yep. They all go upward. Keep that in mind. So there's that. It's B. And we haven't seen A or E yet. So we're looking at just A and E as the last two. Now we can play a little process of elimination or just figure out what they are. Oh, look at these. This is, I mean, I got to write down the problems. You got to do it, right? So y equals x plus 5 times x minus 5. This will be the more spread out one, basically. I think that's A. X-intercepts of negative 5 and 5. Yeah, we go 2, 4, 5 right there. 5 and negative 5 is A. The last one must be E, but let's go ahead and confirm it. Let's write it all down. Y equals x plus 3 times x minus 3. Y equals x plus 3 times x minus 3. You know what else we could do is look at the y-intercepts of these things. For example, you multiply 3 and negative 3, you get negative 9. That'll be the y-intercept of this. We can confirm that too. But the x-intercepts, so that's something I could have done. I could have looked at the y-intercepts as well. The x-intercepts are negative 3 and positive 3. And it looks like E should be it. Yep. Negative 3, positive 3. The x's go by 1s. The y's go by 2. So look at this. 2, 4, 6, 8. And halfway between 8 and 10 is 9. Negative 9 in this case. And that would have been that y-intercept. So that seems to match. Yeah, we could have found all those as well. But that's going to be E right there. And that is up to 34. Pretty fast. I'm threatened by the fact that some are going to be, oh, we got to graph these. See, they say use the zeros to graph the function. I'm not changing a thing on what I do compared to the last ones. I'm not going to label as much as they require me to unless I feel I need to. Like I'm not doing domain and range, but I'm not going to do anything different than the previous problems. When they say use the zeros, those are the x-intercepts. So f of x equals x plus 2 times x minus 6 is already factored. The zeros, if I don't call them x-intercepts, the zeros are when this equals 0, then x equals negative 2 and x equals 6, right? Those are the values of x and y equals 0. So negative 2, 0, 6, those are x-intercepts. So nothing changes there. So negative 2, 0, 6, 0. They didn't ask us to label anything, so the less I write, the better. Maybe I'll write them as ordered pairs next time instead of x equals. We'll see that. I still want my axis of symmetry, though, right? It's still halfway in between. Halfway between, the distance between negative 2 and 6 is 8. Half that distance is 4. Remember that number. Does anyone remember what to do with that number? Axis of symmetry is x is negative 2. Now, if I knew that 4 and negative 4, those are actually really helpful because 4 times negative 4 will be this other part of the vertex. It's a 1. So f of 2 for axis of symmetry, right, is going to be 2 plus 2, 4, times 2 minus 6, negative 4, which is negative 16. They didn't ask me to label, but my vertex is at 2, negative 16. So again, less labeling might save me. Stretch factor is 1. I'm going to go 1, 1, 2, 4. Check this out. We didn't have standard form, but 2 times negative 6 will be your y-intercept of negative 12. 3, 9. 4, 16 is right there. 5, 25 would be all the way up here. And I can't fit 6, 36. So I'm going to leave it and graph it. Yeah, no different from the other problems outside. I'm going to label less. I'm only going to write down what information I need to calculate, but I'm not going to write down the vertex. I'll just say it, things like that. I'm pretty good on using the axis of symmetry by my means. I assume you probably don't necessarily know how that always happens, so I'll be careful when I say what I say. Or if I skip steps that you would normally go like, wait a minute, I need to write that step. G of x, but I'll keep reminding you of it to see if you can kind of connect the dots. No pun intended. And keep in mind, negative 3 multiplies by your values when you try the y value of your vertex and for your y-intercept. Okay. listen, the zeros are the x-intercepts, so after this I'm probably not going to label them. They're -1 and -7. I'm just going to go and plot them after this. So -1 and -7 are your two zeros, your two x-intercepts. Half the distance between -1 and -7 is 6. Half that distance is 3. Yes, x equals -4 is the thing, but we are going to multiply 3 times -3 times -3. We're going to get 27 as our vertex, y value for our vertex. Axis of symmetry is x equals -4, so g of -4 is -3 times -4 plus 1 times -4 plus 7. 9 times that is 27. Now I can't fit that unless I go by, I'm going to go by threes just to kind of work my stretch factor here. So 15, 30, it's not going to go quite as tall as this, 45, and -15, -30, -45, as these just go by ones, or 5 and -5 and stuff like that. Okay. -4, comma 27. 18, 21, 24, 27 is right here. If I go over 1 down 1, that will indeed be truly over 1 down 3 because my scales go by threes. So perfect. 1, 1, 2, 4, or 2, 12. 3, 9, or 3, 27 is right there. The y-intercept, -21. So I can, -18, -21 is right there. That's over 4 down 16, or down 48. Can I fit one more? The problem is when I see these numbers, they confuse me. So that's not a 30, that's a 9 to me, 25, 16. Yes, I think I can fit that right down here. Let's get it. Hey, if you're just copying things down, plot what I plot. You're going to have to pause it or slow it down, though. Plot less or use a table if you got to find them. Once again, if you're, I'm teaching this a very specific way, and maybe you go like, wow, how do you do that so fast, right? If you can work toward that efficiency, great. That's based off the things that I taught previously, though. So hopefully you're picking up on it and you can use it, or at least follow along. If not, use a table and confirm that you get what you get, or plot less points. You can see that the book really said, plot through the points that we got, and it's only like 2 points or whatever, but you can still do it. All right, y equals x squared minus 11x plus 18. This will factor to x minus 9 times x minus 2. That leaves us with x-intercepts of 9 and 2, or zeros of 9 and 2. So here and here. This is one of those where the distance between them is 7. Half that distance is 3.5. So hey, we're going to multiply 3.5 times -3.5. Your vertex is going to be at this x, 5.5 comma -12.25. You ready? So that's 5.5 right there. X equals 5.5. Let's substitute for the vertex, 5.5. 5.5 minus 9 times 5.5 minus 2. 5.5 minus 2 is 3.5. That must mean this guy is -3.5. And -3.5 times +3.5, we've seen it a couple times now, is -12.25. So yes, your vertex is at 5.5 comma -12.25. The scale is normal, or at least I can treat it normally. That's a quarter of the way there. 18 doesn't fit on the graph quite. It's just off of it, but that is my y-intercept. And neither does its reflected point. That really doesn't go on here much, but probably over here at 11. It's kind of like that. Kind of far apart. Stretch factor is 1, so I can go 1, 1. 2, 4. Yeah, suddenly I can't count when I'm on these things. 3, 9. 4, 16. Probably there. Whoops. Not there. Not there, there. 5, 25. Like that. And this one's already kind of off the graph here. So, okay. Looking good, sport. Look how tall. Tallest graph on record. So many points. Oh, man. So good. I feel like there's a void right here where I should have been able to get more points. Is something wrong on that side? Well, the thing that's wrong is I don't know how far those actually go off looking like that because they're off the scale. And that's too V-shaped there. I really got to curve that. Don't make it V-shaped, please. Okay, that is number 37. Number 38. Look at that big y-intercept. Let's please try and keep them a little closer. Thank you. Very nice. Number 38. I don't know what graph paper they expect us to use. You know, books never kind of say, here's a resource page that we'd want you to use on this. They kind of say, hey, just scale by this, kid. You know? We're going to factor this thing. This is x minus 6 times x plus 5. So, okay. 6 and negative 5 are your x-intercepts. Your y-intercept is negative 30. Can't fit on the normal graph, but if we go by 2's, it can. We'll see if we'll have to, based on the vertex. We probably will have to. So 6 and negative 5. Yeah, this seems pretty separated. 6 and negative 5 are your two zeros. You want to average them again? We haven't seen that for a while. Your axis of symmetry. X is 6 plus negative 5 over 2. That is 1 over 2. That's 1/2. So 0.5 if you want to put that. But I go 0.5. Yeah, let's do it the conventional way this time. Let's not do half the distance and things like that. Let's figure it out. So the vertex y value, we're going to take 0.5. I'm going to do it in the factored form. 0.5 minus 6 times 0.5 plus 5. 0.5 plus 5 is 5.5. So this must be negative 5.5 here. 0.5 minus 6. Yep. Negative 5.5. I don't know 5.5 times negative 5.5, actually. Can I speculate what it is? No, I'm not going to. Let's see. Calculator time. 30.25. I might have known that. Negative 30.25. So, yeah, this is going to be out of our picture unless we go by 2's, which is what I'm going to do. So I'm going to go by 2's. 2, 4, 6, 8, 10, and 20, and 30, and negative 10, negative 20, negative 30. Okay, negative 30.25. So they go by 2's. So a quarter of that would be an eighth of the way down like that. These are going to go up by 1's. So this is going to be really tough to kind of get some points off of, especially because the y-intercept is so close at negative 30. It's right there. That is actually my 1, 1. Because, oh, no, it's not. This is my 1, 1 right here. Like that. It's just halfway up because we go by 2's. Does that sound right? 1, 1. Negative 30.25. Wow. That looks a little linear for my taste. I feel like, oh, quarter of the way. That seems linear. I'm not sure if I kind of said that one right. 2, 4. 2, 4 is just going to be like that. I'll just go based off these the rest of the way. 2, 4. 3, 2, 4, 6, 8, 9. Oh, I'll do one more. 4, 1, 2, 3, 4, and 16. 2, 4, 6, 8, 10, 14, 16, 8. Oh, 16. Wait. 2, 4, 6, 8, 10, 12, 14, 16. I can't count. So I'll do those ones there. My up 1 is kind of off because it's actually got to go right. I'm actually an eighth of the way away from there, so it actually goes up a little more. That makes a little more sense now. All right, that'll be enough for that one. That one's tricky. That one's very tricky because of I'm going by 2's, and that thing's a quarter of the way, which means it's really an eighth of the way if I'm going by 2's. It's just, I don't know how much to explain that. It's just the shift of the graph. We do what we can, right? It's the problems they give us. Number 39. Wave difference of 2. Oh, excuse me. We have a GCF here. 40 looks like we have a difference of 2 squares. 39, we have y equals negative 5x squared minus 10x plus 40. How do the Phillies beat the Braves again? Negative 5 times, that'll be x squared plus 2x minus 8. And that factors into x plus 4 times x minus 2. Okay, so yeah, we'll probably have to stretch again here. So your x-intercepts are going to be negative 4 and positive 2. Okay, so we'll get negative 4. Negative 4 and positive 2. Halfway between that's negative 1. They're 3 away each way. Listen, I'll let you plug it in this time. Negative 1 into there. But I'm going to do 3 times negative 3 times negative 5. That'll be 45. So I'm going to get a vertex of, I'm going to write it down because I didn't tell you otherwise. It'll be negative 1. That's the x value, comma 45. So you can plug it in, but that's what you're going to get out of it. So 45, I definitely got to go by 5's for this thing. Or, well, not 5's, but I will because the stretch factor is 5. That'll help me. So this will be 25 right here. 25, and then 50, and then 75. Whew. Negative 25, negative 50, negative 75. So 45 will be just 1 away from 50 right there. That works out. Now when I go over 1 down 1, it's over 1 down 5. So that does work. So I can do my 1 1 2 4 like that, and my 3 9 hits the x-axis like that. This is my y-intercept of 40, right? 40, 45, 50 like that. We can keep going. 4 over down kind of that 16-ish, or down 80. 525. I'm going to go down 125, guys. Check this out. I'm going down 125. It's going all the way from 45 to negative 80. That's 125 away. Yes, scale things by 5s, and you can do all that you'd like. I really like to scale. You can tell. I really like to scale, like if I'm forced to. I really like to scale by my A value increments, because then I can just treat it like a 1-1 kind of graph, right? The x's are going normally, but the y's I can treat like that. Now I can just say 1-1 instead of 1-5, and I don't have to count anything. It's cool. Works out. So when they do that to me, I'm going to do it back to them. You know what I mean? Yeah. All right. H of x, 40. I don't think I have to scale this one. H of x equals 8x squared minus 8. I got a GCF of 8 to get x squared minus 1. X squared minus 1 factors into x minus 1 times x plus 1. That means I have zeros of... Oh, let me move this down totally. I'm sorry about that. I have zeros of 1 and negative 1. 1, 0, and negative 1, comma 0 are my x-intercepts. 1, 0, negative 1, 0. Now this one, listen, you don't have to calculate anything on this one. The axis of symmetry is right in the middle. The right in the middle is the y-axis. That means your y-intercept is also your vertex. My y-intercept is right here. That is my y-intercept. So negative, I don't have to calculate anything, but you plug in 0, 8, whatever, you get negative 8 out. So boom, okay, we got it. And I'm just going to scale normally. So if I went over 2, I'd go up 4 times 8, which is 32. I can't fit 32 off of this. This is just kind of as tall as this is just as good as I can make it. Now listen, this is going to go up so high up like that I don't even hit x equals negative 2 yet, or x equals positive 2. So make sure you don't cross that if you're going to be going, if you're going to be going over like that. Should be getting close to it actually, but not quite there. Definitely shouldn't cross it. So like that, totally. Very, very tall if you don't change the scaling, and I did not. Great. That helped me find my points very well. Okay, let's move forward. Halfway done? Hope they go faster. Number 41 and 42 describe and correct the error in finding the zeros. So here they say y equals 5 times x plus 3 times x minus 2. The zeros of the function are 3 and negative 2. Not quite. They should be opposites of them. So they're saying correct the error. So their zeros should be opposite of what they see in the factorization. And here's going to be my answer, negative 3 and 2, because when we set y equal to 0 and solve for x using zero product property, then they will switch signs while solving, right? X plus 3 equals 0, x equals negative 3. Subtract 3 from both sides. X minus 2 equals 0, x equals 2. Add 2 to both sides. That's what happens. So they didn't swap them. Things didn't work out, right? If I plug in 3 into here, 3 plus 3 is 6. 3 minus 2 is 1. 5 times 6 times 1 is not 0. But negative 3 plus 3 is 0, and you multiply it, right? So you need to plug in the value of x that will get you 0. Y equals x squared minus 9. The 0 of the function is 9. No, it is not. You're not solving you're solving for x squared kind of right now. They go to 0. They need to factor. They need to factor. There's another way to solve, but we're not doing that right now. It's solving using square roots. But they need to factor this difference of two squares to solve using zero product property, basically. They selected an incorrect answer. I mean, it's not, if it said x minus 9, yeah, it would work. They solved it as if it said y equals x minus 9, not y equals x squared minus 9. That took longer to do that squared than I thought it would. So let's correct it. Let's factor. Trying to be tricky. Difference of two squares, right? I think we even factored this one earlier. Y equals x squared minus 9. Okay, that factors into y equals x plus 3 times x minus 3. Therefore, your zeros, the zeros are of the function are -3 and 3. Okay, not 9. See, I substitute. So listen, it's an easy question. Does 9 squared minus 9 give you 0? We're asking what value of x gives you 0. No. Does 3 squared minus 9 give you 0? Yes. Does -3 squared minus 9 give you 0? Yes. All right, 43 to 54. That is 12 problems, or hopefully that's just a fast section. Write a quadratic function in standard form whose graph satisfies the given conditions. They might not necessarily be fast. Depends on the problem. And they say write a quadratic function. It's open-ended on some parts sometimes. We have a vertex of 7 and -3. Remember, we have y equals a times x minus h squared plus k form right here. This is your h and k. So we can write y equals a times x minus 7 quantity squared minus 3. Now, we need to plug in an a value into here. We need to substitute our own. Last time in the example, they used 1. I'm going to use 1 for this one. I'm going to swap it up for different problems. But having a 1 here also means you don't need anything at all. But we need to write it in standard form, which means we need to expand this guy right here to start. So we're going to get x squared minus 14x plus 49. Again, that's a chapter 2 thing. Minus 3, which is y equals x squared minus 14x plus 46. And that is n answer. Any other answer is whatever you have a as. If a is -1, we swap the signs. If a is 2, you double these values. Well, you double these values right here, and then you do the -3 after. So it just depends on where you're at with it. But that's n answer for number 43. Okay. Number 44, same biz. It is a vertex. We're going to use vertex form for the same thing. So this time, let's choose a different number. Let's do -2 for our a. Y equals -2, sure, times x minus 4 quantity squared plus 8. Now, the reason I also wanted to show this is because how we expand. We do x minus 4 squared first. So -2 multiplies by x squared minus 8x plus 16. There's a plus 8. Now we distribute -2. So -2x squared plus 16x minus 32. There's a plus 8. And this is y equals -2x squared plus 16x minus 24. So again, these are open-ended. If you're just following along with me, you'd have to choose your own numbers, really. If you choose mine, fine. But understand what you're doing with it if you want to try it on your own. Number 45, x-intercepts of 1 and 9. So x-int of 1 and 9. This is all about factored form for us now. Keep in mind, so here's kind of what it means. If x equals 1 and x equals 9, I'm not going to do all this stuff later, then x minus 1 equals 0 and x minus 9 equals 0. These represent factors. These are factors for our equation. We can do y equals x minus 1 times x minus 9 like that. These are the zeros for this thing. When we set y equal to 0, we can solve. It's the backwards version of what we would do in zero product property. So now we set it as y equals, right? But they want standard form. So let's FOIL this thing out. This would be x squared minus 9x minus 1x is minus 10x and plus 9. That is an answer. Of course, if they had an a in front, we could use that. You'll see me use an a on the next problem just because. All right, number 46. Let's use that a. And this is where I can go a little faster. X-intercepts of -2 and -5. This is where x plus 2 and x minus 5 exist in your equation. Let's put a fraction this time. We have x plus 2 times x plus 5. Yeah, you don't want to copy me anymore now, do you? So it's 1/2 times, let's FOIL that, x squared plus 5x plus 2x plus 10. And let's take half of those for standard form. Distribute everything. We are going to get 1/2 x squared plus 7/2 x plus 5. Just because I wanted to, we got it. They go pretty fast. I think these are good. Number 47. Now this time we are a little more hand-tied. Is that the word? Hand-tied? We're going to go through the points -4, 0, positive 3, 0, and 2, -18. This time we don't choose an a value because it's got to hit this point. It chooses for us. These are both x-intercepts. X-intercepts, which means the same thing as it meant last time. If x equals negative 4, excuse me, if this is an x-intercept, then x plus 4 is a factor. And x minus 3 is also a factor. Now, the thing about this a is we don't know what the a value is yet because we have to specifically pass through this x and this y. So let's substitute negative 18 for y in this equation. Let's substitute 2 for x in this equation, like this. And then let's figure out what a value would represent that one, right? So here, we're going to get negative 18 equals a times 6 times. Notice how these aren't opposite things anymore. This isn't the x value of the vertex, not necessarily. I don't know what it is. Yeah, it would. But this isn't the x value of the vertex. This is just some value. So these aren't necessarily opposites anymore, right? So negative 18, why did I turn blue? Equals negative 6a, divide both sides by negative 6, you get a equals 3. Now your equation will restore y in x. It's for the entire parabola. So we got 3 times x plus 4 times x minus 3, given that a and that x, those factors. We have to still get it in standard form. This is intercept form or factored form. Let's FOIL this thing out. We get x squared plus x minus 12. And let's distribute 3. We get 3x squared plus 3x minus 36. Okay, that's the one answer. There's only one answer there. Let's do the same thing for number 48. I don't have to write out that those were x-intercepts this time. It still might take about as long. Hopefully you know what we're substituting now for this to work, though. So we're going to pass through negative 5, 0, negative 1, 0, and negative 4. That's an and negative 4, 3. These are your x-intercepts. That means we for show have x plus 5 times x plus 1. Let's solve for a, plugging this in for x and this in for y. That's why I went to blue. So y equals, that's 3 equals, a times negative 4 plus 5 is 1. Negative 4 plus 1 is negative 3. So 3 equals negative 3a, and a equals negative 1. So now we have an equation that says y equals negative 1, or negative, x plus 5 times x plus 1. Let's FOIL that out. Keep the negative on the outside to begin with. X squared plus 6x plus 5. Distribute the negative. We'll get negative x squared minus 6x minus 5. On the second problem of each of these, I'm not going to sit around spending time doing it if we do one already. All right, passes through 7, 0. This one's interesting. This is so open-ended. It doesn't tell us, wow, through 7, 0. I'll tell you what, there are so many answers here. They said a quadratic. You can choose your other x-intercept. Remember what I told you also before? Maybe this is the only x-intercept here. What if this was the only one? Maybe they want you to treat it like that. Maybe like, hey guys, this is the only x-intercept you hit. That's not necessarily true. They didn't give us any of the restrictions. But if this was 7, 0 and you had a graph that just did that, how's that possible? That is if you have a repeated root where you have, say, x minus 7 times x minus 7, x minus 7 squared, right? So this is one version. I'm going to give this answer. This is one version of an answer. X squared minus 14x plus 49. It's the only x-intercept. 49 apparently your y-intercept. It goes up to there. But that's your only x-intercept, and there's one. It works. You can choose another one. You can choose 8, 0, 9, 0, 20, 0. But I'm doing one that kind of works that way. I kind of like that answer. Number 50. We're zooming along. We're going through the origin, 0, 0, and 6, 0. They don't restrict our a. This time, remember, x equals 0 means x is one of your factors. So they don't restrict our a. We can plug in whatever we want. This is x times x minus 6, like that. Let's put in a, though. Let's put in 3. 3 times x. 3x times x minus 6, right? Insert your own. Let's go. I inserted on my own. 3x times x minus 6, distribute that. We get 3x squared minus 18x. Totally. Working it out. Axis of symmetry of x equals negative 5. Once again, they do not string you very tightly at all. You have so much to work off of. But you need to be consistent with how a parabola would work off this. So axis of symmetry of x equals negative 5. Points need to be symmetric with it. So we can choose your form. You can use factored form. You can use vertex form, whatever it is. And it's hard to make them both the same, as in if I said, I'm going to make vertex form look like this, and this is the equivalent to this factored form. But if I do some vertex form version, I just got to make sure that this is my h. So let's say I did y equals, I'm going to choose 1 as my a. So a times x minus h, so plus 5 squared. You can make your k whatever you want. I'm going to make it minus 6 plus k, like that. So this is a version. So we'll have x squared plus 10x plus 25 minus 6, or x squared plus 10x plus 19. There's something. Or if I use factored form, here's all you have to make sure you do. I'm going to use 1 as my stretch factor again. Make sure your 2 points, your x-intercepts, are the same distance away from negative 5. Let's say they were both 2 away from negative 5. Then we would use negative 3, 0, and negative 7, 0. Those are both 2 away. 2 away from negative 5. They have to be the same distance away. So I'd have x plus 3 times x plus 7, right? That's not the same graph as this one. These are just different. This or that. So vertex form, factored form. It has to be the same distance away. So you have to follow the nature of what this is. You can either choose this x value for your vertex, choose your own y, or choose the same distance away from here to make something. So this would be x squared plus 10x plus 21, like that. So different kinds of answers. I made the a value 1 to keep that part easy, and that's what you get. 52 looks interesting. Y increases as x increases when x is less than 4. We're going to draw something out with this. And y decreases as x increases when x is greater than 4. So x increases means going to the right. Okay? So if we have a graph, just go with me here. Let's say this was our... So it says x is less than 4, x is greater than 4. That means 4 is where your vertex exists. Let's say it's there. Y increases as x increases. So as x goes over, y is going up. So it's going up during that time. And then y decreases as x goes to the right when x is greater than 4 on this side. So it's an upside down graph. So you're not too hamstrung. You have a couple things in mind you have a couple things to keep in mind, and we can do the same things last time. Vertex form or factored form, because we just know the axis of symmetry is at x equals 4. But you do have to make your graph go upside down. So you have to make your a value negative. That is the one requirement beyond the other stuff here. So let's just use vertex form this time. So I'm going to go off of vertex form, and we're going to say y equals, let's use negative 4 as my a value here. Why not? Times x minus 4 quantity squared. I have to use that here. They don't tell you anything else about what the vertex has to be. Let's go kind of high up. Let's go plus 20. Why not? 4 comma 20 is my vertex. Sure. But it's negative. It goes downward. Now, negative 4 multiplies with x squared minus 8x plus 16. There's a plus 20 there, but negative 4 distributes first. That's negative 4x squared plus 32x minus 64 plus 20. Or y equals negative 4x squared plus 32x minus 44. Okay, remember, they asked for standard form each time. That's what we're practicing our expansion. These problems are kind of fun when we do these. Range, 53 and 54. The range is all about where your vertex is located on y. This is another version of where vertex form would be quite splendid to use and go off of that. So if your range is y is greater than or equal to negative 3, that makes this a minimum. That means somewhere here it's hitting negative 3, something x comma negative 3, or h comma negative 3. That's a minimum, and it goes upward. So we have to know that it's an upward facing graph. I can use positive 1 as my a value. I can choose my own h for my vertex. So I can say x minus 5 squared minus 3. This needs to be my k, and I need to go upward, so this needs to be positive, right? So let's expand that. X squared minus 10x plus 25 minus 3, and that's x squared minus 10x plus 22. I love this open-endedness of these problems and realizing what they mean when they have you do it. It's very conversational, and you have to make sense of what your forms are to make them happen. Number 54, last one in this set, y is less than or equal to 10. It's the same kind of thing. I don't mind using vertex form for this. It's a pretty nifty idea. That being said, if it's less than or equal, that means we go downward from the top. This is a maximum. This graph goes upside down. I'm going to have to choose an a value that's negative. So this time let's use negative. Let's go back to negative 2. Old classic. And let's do x plus 1 squared, sure. And plus 10. That's our k value of our vertex. Let's check that out. That's negative 2 times x squared plus 2x plus 1. That's the expansion. Negative 2 gets distributed. and negative 2 plus 10 is 8. So we'll get y equals negative 2x squared minus 4x plus 8. These problems are kind of, if I were to do notes for my students and use these as examples, it's kind of hard to give all the different detailed versions of what you can have. And I'd rather not give them all. I'd rather not say, hey guys, if you have the range, make sure you do this. I'll tell you guys because we're doing a solution guide. But other than that, it's like have the conversation about what the range represents and what form we would need off that. Sometimes you can use more than one. 55 to 58, write the quadratic function represented by the graph. Now, I could do this faster than I'll teach it. Sometimes maybe I'll say what the answer is beforehand. Ooh, I couldn't necessarily yet here because, okay, they give us factored form. Okay, this is, you know what, we'll do it the same way as before. That's fine. I'm not going to play off the vertex. I can't guarantee what the vertex is, but they tell us exactly what I can say. It's the same stuff as before. Through negative 3, 0, through 2, 0, and through 1 comma negative 8. So I am hamstrung by whatever a value they kind of make us use. I know that I have x plus 3 as a factor and x minus 2 as a factor. We're going to substitute this for x, this for y. So I got negative 8 equals a times 1 plus 3 is 4. 1 minus 2 is negative 1. It's negative 8 equals negative 4a. Divide both sides by negative 4, you get a equals 2. They say write in standard form? No. They just say write the quadratic. Right. These ones before said write in standard form. Here they say write the function. Factored form or anything is, I think, fine. So y equals 2 times x plus 3 times x minus 2. It's fine. They don't say standard form. This is a quadratic. It works for me. Factored form, once again, this is the factored form, the intercept form section. So I think at some point they want us to probably should have used intercept form on that one. 52, I said vertex form. Oh man, we're in this section here. We did vertex form last section. Same bits, same ish, same bits, same ish. That didn't come out right. Let's see what the closed captioning says on that. I apologize. I don't want to get demonetized or something for that. The playoff game will demonetize me. That's it for sure. All right, we're going to go through 1, 0. Same ish, same bits. Okay. Through 1, 0, 7, 0, and 6, 5. I've said worse on camera. Much worse in a classroom. So again, we're hamstrung by this to get the specific a value based on that. So we're going to do y equals sum a times x minus 1 times x minus 7. Those are the factors of those x-intercepts, because that's what they are. These are x-intercepts. When y equals 0, that's what we have. I don't know if that was fully explained. 5 is our y value, so substitute that. 5 is a times 6 minus 1 is 5. 6 minus 7 is negative 1. 5 equals negative 5a. When you multiply that, divide both sides by negative 5, you get a equals negative 1. We can write in whatever form we want. I'm going to stick to factored form. Negative 1 times x minus 1 times x minus 7. Okay, 57 and 58, more of the same. Literally more of the same. There are still intercepts, so it's just repeats. I'm not going to change what I do at all. So we get through, same bits, same-ish, through negative 2, 0, 4, 0, and 2, 32. Okay, so we can do y equals a times x plus 2 times x minus 4. Here's an x, here's a y. So 32 equals a times 2 plus 2 times 2 minus 4. So 32 equals, that's negative 8 times a. Divide both sides by negative 8, you get a equals negative 4. My equation is going to be y equals negative 4 times x plus 2 times x minus 4. All right. Yep. Same process, not changing. Try one before you watch my video, right? Try number 58 if you followed along and understood what's happening here. And make sure, you know what I haven't been checking? Make sure that it confirms this is a negative stretch factor. Confirm that this thing should be going upside down, right? It does. Just make a confirmation because maybe I messed up. I don't think I did. But if I messed something up here and there, I didn't double check it. And that's something you might want to do. And that could definitely happen if you don't change maybe one of these signs, something like that. All right, number 58, we're going to go through. I'm writing the x-intercepts first. So 6, 0, 10, 0, and 8, negative 2. Looks like 8, negative 2 is the vertex. You guys see that? 8, negative 2 is the vertex. So listen, I'm going to do standard form for this in the end because I want to show you that I could use vertex form or factored form for this. So in factored form, I'm going to say y equals a times x minus 6 times x plus 10. Because I know for sure that this is the vertex, and they tell me what the number is and stuff. It's right halfway in between these, all that. I'm going to substitute 8 for x, negative 2 for y. So negative 2 is a times 8 minus 6 times 8 plus 10, 18. So negative 2 equals 36a. Wow, is this that? Yeah, this is just a string. Is that right? A is negative 1/18. I'm gonna double check that. Oh, x minus 10. That is wrong. That is wrong. That seemed way off there. X minus, see, that'll change things. You know what? Shouldn't be negative either, right? Shouldn't be negative. It should go upward. So let's fix that. Negative 2 equals a times 2 times 8 minus 10 is negative 2. Oh yeah, it's a vertex, right? We should have gotten opposite values. Hello. So negative 2 equals, and this is fine, negative 4a. It'll be a fraction. This is the one I expected. A is 1/2. There we go. So the factored form of this equation is y equals 1/2 times x minus 6 times x minus 10, which is a fine answer. I'll box it. But I'm going to also expand this into standard form. So this will be 1/2 times x squared minus 16x plus 60. And then that expands to 1/2 x squared minus 8x plus 30. This is standard form. I'm going to get standard form as well out of vertex form and show that I get the same answer. How can I use vertex form? I have a vertex. And I can use either of these as an xy value or point. I can do some other things. I've talked about stretch factors. You go over 2, we'd go up 4, now we're going up 2, things like that. But I'm going to go ahead and use the points. So vertex form, we would say y equals a times x. Here's my h. X minus h squared plus k, like that. Let's substitute one of these for x. Let's do this one. Negative 10, or 10, excuse me, 10, 0. 0 for y, and 10 for x. That's 10 minus 8 squared minus 2. 0 is, 10 minus 8 is 2. 2 squared is 4. So 4a minus 2. Add 2 to both sides. And divide both sides by 4. You're going to get 1/2. Now that doesn't confirm we got the same answer just yet. Let's make sure that we write that in the form. But it's a good sign. So y equals 1/2 times x minus 8 quantity squared minus 2. Now let's expand that. But this is vertex form, once again. Let's expand that to 1/2 times x squared minus 8x plus 16 minus 2. Let's distribute 1/2. Excuse me, what did I just say? I was thinking of 4. X squared minus 16x plus 64 minus 2. That's 1/2 x squared minus 8x plus 32 minus 2, which is 1/2 x squared minus 8x plus 30. So standard form, we get the same answer regardless of which one we do. They only really wanted factor form. I could have used this and stopped right there. It would have been good. But showing that it's the vertex means we could have used that. But hey, this is a factor form section. They probably wanted you to use that one. But they gave me a vertex. Why not? 59 and 60, all the zeros of the function are given. That's true. They gave you both the zeros here of a quadratic. There's one, there's one. And here, there's one, there's one. When y is 0, those are them. Use the zeros in the other point given to write a quadratic function represented by the table. These problems are no different. They're just giving you representations in different ways on these. So this xy here means we're going through the points 0, 0, 7, 0, and 2, 30. That means these are the intercepts here. These are the zeros. So as far as an equation goes that I can begin with, I can say y equals, now listen, we're still hamstrung by some a times, listen, x, if x equals 0, then x is one of your factors, right? A times, I'll just put in parentheses, a times x minus 7. So that's the one little tricky part, right? But that's one of the zeros there. We're going to go through 2, 30. 2 is the x, 30 is the y. So 30 equals a times 2 minus 7. Boom, like that. 30 is negative 10a, and a will be negative 3. They still don't say standard form, so I'm not hamstrung. I'll go ahead. Well, I'm hamstrung to get my a, but I'm going to go here. Negative 3x times x minus 7. That is a factored form answer. It is brilliant because they didn't say standard form. Number 60. Number 60. Number 60, we have xy values of x-intercepts, negative 3, 0, 4, 0, and somewhere in between, we got 1, negative 72. That is big. So let's see here. We are going to get, how do I want to say this? Y equals a times, I got an x plus 3 for that 0, and x minus 4 is the other 0. Here's our xy we're going to plug in, so negative 72 for y, and 1 for x, so a times 1 plus 3 times 1 minus 4. So that's negative 72 equals negative 12a. Divide both sides by negative 12, I think that's 6. You get a equals 6. So this equation is going to be y equals 6 times x plus 3 times x minus 4. Write a quadratic. Yep, no standard form required. That is those ones. Going pretty fast in that part. So far we've gone almost 2 hours. Okay, I think we're in better shape. No word problems yet. 61 to 64, sketch a parabola. Oh, there it is. Sketch a parabola. It's a little too soon. If I didn't say anything, there wouldn't have been word problems. Sketch a parabola that satisfies the given conditions. So now I'm going to have to go back to here, I guess. X-intercepts of negative 4 and 2. X-int of negative 4 and 2. Range y is greater than or equal to negative 3. So negative 4 and 2, here's the thing on the range. That will be the bottom, because the graph's going to go upward. That will be the bottom, the vertex value. The y value is negative 3. The x value is half the distance between these. These are 6 away. Half is 3 away at negative 1. Negative 2, negative 1, negative 2, negative 3. That's our vertex right there. Vertex is going to be at negative 1, negative 3. I don't have to plug anything in. It's just sketch a graph. I don't necessarily have a need to find more things than this. I could tell you the stretch factor is going to be 1/3. I'm not going to tell you, over 3 up 3 instead of over 3 up 9. So I could find more points for you, but they said just sketch it. I think their goal is to get you to find that vertex. But you know what? The rest of my graph will now be inaccurate because I'm so used to finding other points. 3 points for me on a parabola, honestly, it's not enough for me. Look at this. I can't. I'm just like that. But that's your vertex. That's the important part they really want. And the fact that it faces upward, I guess. Number 62. You have an axis of symmetry at x equals 6. Let's check this out. Let's just go down. 62. Axis of symmetry. Ooh, my back. At x equals 6. It goes through the point 415. Which I can fit on this graph. So x equals 6 is right here. That means the vertex is somewhere on here. We can do whatever parabola we want, provided that we hit 4, 15. Now, if we hit 4, 15, which is right here, by the way, that means it should be able to reflect across this over here and hit this point as well. That's the biggie on it, right? And your vertex needs to be somewhere on here. That's the only information they require. So as long as my vertex is on here, even like this, I can make a nice wide parabola going downward, and I'm totally good. Now, this parabola would have a value of negative 1/4. I didn't actually find any stuff beyond that, but they just want to make sure you're getting the features, and I think that'll work. Number 63. Range, y is less than or equal to 5. What's interesting is this isn't really factored form anymore. Like I said, sometimes they kind of throw other things. I mean, they'll give us some, I'm sure. But range y is less than or equal to 5. And through 0, 2, which is a y-intercept. What was I saying before? What's interesting is these aren't necessarily factored form things anymore. Sometimes they throw in other things that just have to do with other things. We're kind of mixing forms now because we've taught them all. This is the last one to teach. We hit 0, 2. The range y is less than or equal to 5. Somewhere, your vertex is somewhere on here. I'm going to put it right there. I'm going to put my vertex right there, which means I got to reflect across that for sure. I got a stretch factor of negative 3. If I really want to get another set of points, I'll go over 2 down 12. Like that. Yeah, let's get some other points on that for sure. Looks great. Oh, now it looks terrible. Even with points, I can't actually hit them through. So there we go. It should go downward. And then number 64. X-intercept of 6. These ones are tricky because I don't know if they're saying it's the only one we're allowed to have. Y-intercept of 1, range is y is less than or greater than or equal to -4. No, definitely not the only one. Because if that was the only one, that would be the vertex. So definitely not. What we want to check out, let's plot some of these points. I got an x-intercept here, one of my x-intercepts. I got a y-intercept right here. My range, I'm going to kind of draw, this isn't an axis of symmetry, but I'm going to draw a dotted line over here to say that my vertex needs to be on this line, somewhere on this line. Now check this out. There's symmetry to this. So if it needs to be on this line, it needs to go upward. That means somewhere it needs to hit, here and come back here and such. Now, what we need to do, I'm trying to figure out if like we were required to find an actual vertex here, but it's somewhere in between, and it's going to be closer to here than there, because the other x-intercept would hit, somewhere in, right? And it's going to hit somewhere kind of on that area. It's not going to be a perfect graph unless I make it one. So can I make this a perfect graph? I have 3 different sets of points. One's an x-intercept, one's a y-intercept, maybe? I'm trying to think of what form. I definitely can through one set of means, but we didn't do that yet at all. So I'm trying to think, like, can I do vertex form? No, because I have k, I don't have h, and I can choose an x, y given an a. Oh, I don't have a. Can I use factored form? No, I don't have the other x-intercept, but that's the only other value I would need. Let's try that. No, I still don't have a. I would know only one other way to do this, and it's through a system of 3 equations, and even then, I don't know because I don't have the x value of the thing. I mean, here's a basis of this graph. I just don't know what would be like a really good way to find that exact vertex with you guys. Because I can't even reflect this across something without knowing the axis of symmetry. It's somewhere over here, I guess, but I don't know exactly where that is. So, I might be a little stuck on what I'm going to draw that for now. I'll think about that for later. They say sketch a graph. I really want to find that vertex, and I really don't know how I should with you guys in mind. I'm trying to even confirm I can do it with me in mind there. I'll think about that later. Okay, so there's one version of the sketch, right? We're going to hit -4 as the vertex, like that. I'm really thinking out loud about that one, though. It's got to be within there, though. It's got to be closer to the x-intercept than the y-intercept. I think that's really some of the big stuff to talk about. Okay, I'm going to try this. This will be a system of equations thing. You won't necessarily know what to do, but I want to see what the values are and see if it makes sense. I'm going to use vertex form because I want to find the x value of it. I'm sure there are other ways I could do this, though, too. I'm going to substitute. If y-intercept is 1, that's 0, 1, and this is 6, 0, and we know that this is some h, comma, -4. So my k is -4 here. What I'm going to do is I'm going to substitute, this is beyond what you guys will know. I just want to find it. This is me. I want to substitute 1 for y, 0 for x once. So 1 and 0. And then I'm going to substitute 6 for x and 0 for y. So 0 equals a times 6 minus h squared minus 4. Okay, I'm going to add 4 to both sides on these things here. Let's see where my room is. Let's start with this one. I'm going to add 4 to both sides, and I get 5 equals a times -h squared is just h squared. So boom. Remember, my goal is to solve for both a and h. This is going to be beyond you guys, basically. I'm going to add 4 as far as what you would have been expected to learn. A times, now 6 minus h squared. Oh, this is going to be a big one. This is h squared minus 12h plus 36. Oh, wow. I don't know if this is worth it. If I divide both sides by h squared and by this big guy, a can equal 2 things. A can equal 5 over h squared, and it can also equal 4 over h squared minus 12h plus 36. If I cross multiply here on this guy, that's not the answer. If I cross multiply, I'm going to get 5, I feel like I'm overdoing this, 5h squared minus 60h plus, this is more for me now than for you, plus 180 equals 4h squared. If I subtract 4h squared over, I get h squared minus 60h plus 180 equals 0. And I don't know if that's factorable. 60 times 3 doesn't, well, here, I got to list these out. I don't know if that's factorable. 180 and 1, no. 90 and 2, no. 60 and 3, no. 45 and 4, no. It's not even factorable. You know what? It's not worth it to find it. It's not worth it to find it. It's somewhere in between there. It's just something. It's just, you could find the h. There's something called quadratic formula we could use to solve, but you haven't learned that yet. And the system of equations thing is overdone. So I'm glad that you probably stopped at some part of the problem there. We're just going to leave it. We're just going to leave it and just have a little bit of a graph. I figured they wanted something on it, and that wasn't enough. Sorry about that. I could solve it. It's just, it's not something you would definitely not know. Number 65, modeling with mathematics. Satellite dishes are shaped like parabolas to optimally receive signals. The cross-section of a satellite dish can be modeled by the function shown right here, where x and y are measured in feet. The x-axis represents the top of the opening of the dish. So right there, we've got the top of the opening. How wide is the satellite dish? So first we have this equation, y equals 1/8 times x squared minus 4. Now, I can use the graph to answer that, and I'm going to. So we go from -2 to 2. Straight up, guys, that distance is 4. We've been talking about distances between points so many times that I'm going to go ahead and say that. We've got to make sure we have units, so that distance is 4 feet. That is the width. Part B, how deep is the satellite dish? Once again, I think they just want you to understand the picture. They're not asking you to really do things in that. That distance is 1 foot. That's 1. So the distance there is 1 foot. 1 feet. 1 foot. Part C, write a quadratic equation in standard form that models the cross-section of the satellite dish that is 6 feet wide and 1.5 feet deep. Okay, so, what? I guess they want you to make an equation off that from this. So I understand where the 6 feet wide can come from. I guess we got to do our thing from before. So basically it's this. If we're 6 feet wide, we're going to go from -3. Oh, that's not -3. But we're going to go from -3 to +3. 1.5 feet deep is right here. That also represents your vertex. So we are going to have a few points on this thing. We are going to go through, this is kind of like those last problems, -3, 0, 3, 0, and 0, -1.5. Now I can either use factored form or vertex form because this is the vertex. Last time I used vertex form though, this is the factored form section. I'm using factored form this time. So we have y equals some a times, I think I could figure out what that is for you. If you want. A times x plus 3 times x minus 3. Like that. Let's plug in 0 for x, -1.5 for y. -1.5 equals, let's see, if I go over 3 up 1.5 instead of up 9, this should be 1/6. I think I'm getting a value of 1/6. So a times 3 times -3, that's 0 plus 3, 0 minus 3. So -1.5 equals 9a, -9a. Divide both sides by -9. A is -1.5 over -9, which that's where I think that reduction, 1 over 3. I think that's 1/6. So 1/6 there. So now our equation is y equals 1/6 times, and guess what? X plus 3 times x minus 3 is x squared minus 9. That's that guy. And let's distribute the 1/6 into there because they said standard form. So that'll be 1/6 x squared minus 3 halves. 1/6 of 3, -9 is -3 halves, like that. And that makes sense, right? That's your y-intercept. -3 halves is -1.5. And the y-intercept is the vertex, and it all works out. I like it. Okay, that is 65. Is there a part D? No. Number 66, modeling with mathematics as well. 15 more questions. Oh, I still have more room. Number 66. A professional basketball player's shot is modeled by the function shown. Oh yeah, that is a professional shot right there. Look at that equation. Modeled by the function shown, where x and y are measured in feet. Does the player make the shot? Explain. So what we're seeing is their release has this model, so you don't have to worry about like where this goes or anything like that, or what this is as a point. They have the model for you. We have to figure out if we hit 3, 0, basically. I think that's the idea. Do we hit 3 for x, 0 for y? That's part A. I have this equation, -1/20 times x squared minus 19x plus 48. I'm going to substitute 0 for y, 3 for x, and I'm going to see if the left side equals the right side. 0 equals -1/20 times 3 squared minus 19 times 3 plus 48. Let's see if we get 0 equals 0. The only way, if so, listen, the negative 1/20th has nothing to do with this problem. The question is this 0? That's the only question. So 0 equals negative 1/20th, nothing to do with the problem, times 9 minus 57 plus 48. Yes, which is negative 1/20th times 0. And that equals 0. 0 equals 0. That checks out. Yours. I kind of like that they gave us that answer, because otherwise we'd be going like, I mean, like, what are we looking for, sir? Like, no, he missed. No, he went under, right? I want to know that otherwise. The basketball player reaches another shot, or releases another shot from the point 13, 0 and makes the shot. The shot also passes through the point 10, 1.4. Write a quadratic function, standard form of the models the path of the shot, and try and let your back feel good, because it just started to strain a little bit more in the upper right. So we need to make the shot. That means we hit 3. We're going to go through 3. Our arc is now different. We're going through 3, 0. We're going through 13, 0. We're going through 10, 1.4. So same stuff as before. Same-ish, same bits. We have some x, some y we're going to plug in when we have this factored form based on that. We'll have y equals, totally different model of a shot. Y equals a times x minus 3 times x minus 13. 13. 1.4 for y. 1.4 equals a times 10 minus 3, 7. Oh, that's a little vertex, isn't it? 10 minus 13 is negative. Oh, no, it's not. Wait, 10 minus 3 is 7. 10 minus 3, I was going to say negative 7. We're good. It's not a little vertex. Duh, the vertex is at 8, something. 1.4 equals negative 21a. A is 1.4 over negative 21. Now, 14 over 21 would be 2/3. So this should be 2/30ths. Negative 2/30ths, which is negative 1/15th. Okay, I'm going to use that fraction. No decimals here, guys. No rounding. So this equation is going to be y equals, and they want standard form? Negative 1/15th. I have to keep going on this. Negative 1/15th times x minus 3 times x minus 13. Let's expand that, because we didn't yet, right? So that'll be negative 1/15th times x squared minus, let's say 26x, minus 16x plus 39. And 1/15th of those will just be over 15. Negative 1/15th x squared, unless I mess something up, plus 16/15ths x minus 39/15ths. Now that number can reduce. They can divide those by 3. So that's 13/5ths minus 13/5ths. Yeah, I hope I got the right answer from that. That was a decent fraction, so I'm going to trust it. Looks good. Yeah, 22/3. I think so. 16 plus 39. Okay, let's go to 67 to 70 for questions here, where we're going to match the function with the graph. So we can look at stretch factors to help us out. We can also basically factor these and look at what the factor. They didn't scale them for us, but it's based on whether they hit something or not. Now, I'm going to give you a little hint on something here, because everything here that we've played with has been kind of factorable, right? Well, hold on. X squared plus 5x. I'm going to drop you some knowledge on something. And when I say factorable, I mean factoring out x's to solve things. Not just numbers, not just GCFs, but I mean x's. If you can't factor x's, something with x's in both terms, make it linear to find different zeros, I'm not saying it doesn't have zeros, but in this case it would be the case. Notice how this never crosses the x-axis and this never crosses the x-axis, because it doesn't have x-intercepts, because you can't factor it with x's involved. So that's one hint we can talk about. There are a lot of other things I can bring up. This one can. So this one is negative x factored out, and you have x minus 5. That means you have an x-intercept of 0 and an x-intercept of 5, and this graph goes downward. We should be hitting the origin. This is D. We should be hitting the origin. We should be hitting out here in positive land. It should be going downward. This is totally D. And we can eliminate answers as we go. Number 68. A is 1, so this is an upward-facing graph. That's a good start. So 68, we get y equals 1x squared minus 1x. Don't write the 1 if you don't have to. Minus x minus 12. This will be factorable. This does factor into x minus 4 times x plus 3. So this will have x-intercepts of 4 and negative 3, and this graph will face upward for the positive 1. So we're looking for things on opposite sides. So this one here, it has x-intercepts, it works out, going positive. 4 a little more so, -3 a little less so. This graph is totally A. So the other two aren't going to be factorable by means that we would love the factoring to happen. Let me show you what that looks like. Number 69. Number 69, where we have y equals -2x squared minus 8. Now, there are other reasons we can find this answer, by the way. I just want to talk about the factoring to begin with. So this is -2 times x squared plus 4. X squared plus 4 is not a... There's no such thing as a sum of two squares with respect to factoring with real numbers. This does not factor more. If you use zero product property, you say either -2 equals 0, which is an impossibility, or x squared plus 4 equals 0. And without zero product property in factoring, we can't do that. It doesn't factor more. So this doesn't really help us in that stage. That's the idea. I can't plug in a value for x and get 0 out. I square this number, it'll turn positive. Plus positive is not 0. I can't get that. That's why it never hits the x-axis. So the factoring bit's kind of tough. But if we don't factor, let's go by other means. What do we have? This graph faces downward, and -8 is not only the vertex for the y value, but it's the y-intercept. Y-intercept of 0, -8. This is standard form stuff. Standard form stuff. It's going to be D. It's going to be B. For the very fact it faces downward, it's going to be B. That's, I think, another thing we can mention. It's going to be B. And I think we can say the same thing on number 70. Listen, x can't factor in any sort of way. We can't work that thing out that same way as 69. So what we're going to do instead is, there's only one answer left, but we're going to confirm some things on this. It faces upward. The y-intercept is 0,6. So starting up there, this is going to be C. 0,6 going upward. Never crosses the x-axis. We don't actually get x-intercepts out of this thing. It's going to be C, and that is the answer. All right, 10 more questions, and we are... Let's see if I can fit everything in time. Number 71, write a quadratic function represented by the table if possible. If not, explain why. This is interesting because they give us 4 points, and I'm not ready to... Oh, no, this is fine. This is totally fine. Okay, great. I didn't want to do this whole system of equations thing or what we were doing before. Okay, check this out, guys. So we got x and y-intercepts here at -5 and we have x-intercepts at -5 and -1. So, hold on. Let me write this out. -5 and positive 1. Let me write this out. Okay. Check this out, y'all. Got an x-intercept of -5 and 1. Right? Let's kind of see this on a graph and talk about what I want to talk about. I mean, we could plot them in general, but I want to show you other things on this by spacing. -5 and 1. Now, I'm not all about the vertex and stuff, but what I am about right now is the axis of symmetry. The axis of symmetry is right between here at x equals -2. -3 and -1 for x are both the same distance away from 2. They're right here and right here. Points right here have to be the same height because they're the same distance from the axis of symmetry. These are not the same distance away. Here's -3, 12, or they're not the same height. This is -1, 4. 4. These are the same distance away from the axis of symmetry, but not at the same height. Parabolas are symmetrical. This is not. This cannot be. You cannot write a quadratic function based on this thing here on number 71. So I'm not going to. Explain why. You cannot write a quadratic, or I cannot, function represented by the table, because the points -3, 12, because the x values of -3 and -1 do not share the same y value for symmetry, symmetry purposes, for purposes of symmetry, right? When I say it out loud, I explain it better than when I type it, probably because I say more. All right, number 72. How do you see it? The graph shows the parabolic arch that supports the roof of a convention center, where x and y are measured in feet. So it looks like x-intercepts of, I guess, 75 and 425. I'm going to use those if they ask us to kind of write an equation. And vertex, I have no idea. The arch can be represented by a function of the form here, estimate the values of p and q. Okay, so that's what I'm saying. P is probably exactly, but 75, and q, it doesn't matter which one's which, is about 425. Those are scaled by 25s on those things, apparently. Estimate the width and height of the arch. Explain how you can use your height estimate to calculate A. Okay. So I'm not going to explain it. I'm just going to do it, I guess. So my width is 425 minus 75, which is 350 feet. My height is roughly from 0 up to, these go by 25s, right? So 25, 50. It's about halfway between that and 75. 62.5 would have been halfway in between. Let's go a little lower. Let's go about 60 feet there. Maybe that's what they want us to go. I have no idea. Maybe that's what they want us to go for, but that's the middle, right? 250 is in the middle, not just because it looks like it, because it's halfway between. It's the same distance away from 425 and 75. It's 175 away from both. So that is the kind of vertex thing. Explain how you can use your height estimate to calculate A. I would use, okay, so the vertex, well, not just you can use the vertex, but there's a point on this graph. This goes through 250, 60. So use this xy in y equals A times x minus 75 times x minus 425, because those are those numbers there, to solve for A. Now, they don't ask us to. Explain how you can. Yep, they just say explain how you can. That's it. 73 and 74. Rewrite the quadratic function in intercept form and graph the function using any method. Explain the method you used. Okay. So, I'll probably just use vertex form. On 73, well, listen, I'm going to use every bit of the features that I have to plot points. So when it comes to method, I'm going to use them all. When I get in standard form, I'm going to have my y-intercept. When I have intercept form, I'm going to have my x-intercept. When I have vertex form, I'm going to have my vertex. And I have my stretch factor in all three. Now, they say get it into intercept form, which is factored form. In order to get there, we have to use standard form in between. I don't know if you have to, but that's what I prefer. So that must mean this must be factorable. So, but it's not factorable until we hit standard form with this. So I'm not going to graph first and get the answer. I'm going to go ahead and expand x plus 1 squared to x squared plus 2x plus 1. Again, the key is to get standard form first. We'll have f of x equals negative 3x squared minus 6x minus 3 plus 27, and then combine the negative 3 and 27. So we now have negative 3x squared minus 6x plus 24. Okay, there's standard form. Factored form, basically, we factor this now. So we start with the negative 3 GCF, which was not a GCF before for everything. It was just for these terms. So now it's x squared plus 2x minus 8. And that now factors into x, I think we had this before, x plus 4 times x minus 2. So there's our factored form of this thing. So here are all the features that we have from this that I know. I know we have a vertex of negative 1, 27. I know it goes downward facing graph. Vertex of negative 127. We have a y-intercept of here, 0, 24. And I can reflect a point across the axis of symmetry at negative 1. We have x-intercepts at 4, 0. Next time I'll just write the numbers. Negative 4, 0, excuse me. Of negative 4, 0 and 2, 0. So that's a lot of points I can use to kind of make this thing happen. So those features, let's bring this down. Those features will definitely help me come up with this graph in general. Now I need more. I'm going to stretch them by 3. I'm going to scale this by 3s. Up to 15, 30, and 45, etc. Negative 15, negative 30, negative 45. This was kind of fun because I get to kind of use all the features I have now that I did all that work. I'm going to use what's called the 5-point method. This is another way of using what's called the 5-point method. I remember teaching that way back when. Okay, negative 1, 27. So negative 1, here's 27. It's 3 away from 30. I have 0, 24. That's this point right here. And reflecting across the axis of symmetry is that guy. And I have negative 4, 0 and 2, 0 as these points. That's a lot of them. I can also go over 2 down 4. That's technically down 12, but right there. And that's the over 3 down 9 or down 27 right there. And that's, that's using the graph. So which form did I use? Guys, I used all of them. Vertex form, I think, is the most appropriate say as far as how I got some of these points, because I went off the vertex. I never did negative b over 2a, and I never found half the distance between these get axis of symmetry. I mostly use vertex form with these as featured points. So I used vertex form, and you're likely going to see me do that again for the next one with these as featured points. I'm just going to stop at that graph there for now, though. Kind of running out of time. Number 74. G of x equals 2 times x minus 1 quantity squared minus 2. Let's expand that. That'll be 2 times x squared minus 2x plus 1 minus 2. Let's distribute the 2. We get 2x squared minus 4x plus 2 minus 2. And this will give you 2x squared minus 4x plus 0, right? I don't have to write plus 0, but the plus 0 would also mean what? 0 is the y-intercept, so we'll note that. Let's factor now. I have a GCF of 2x, and this will be my factored form. This is 2x times x minus 2, like that. So here's my factored form with the GCF. So here's what we got. We got a vertex of, let's do this on the left side. We got a vertex of 1, negative 2. We got a y-intercept of 0. We got x-intercepts of 0 and 2. It's unfortunate when y-intercepts and x-intercepts are the same because that's less points that you get. Instead of getting 5 points out, I just get 3, but I can still plot them. So I have 1, negative 2, and this graph goes upward, by the way. It goes upward. I have 1, negative 2. That's my vertex. I got 0 and 2, like these is my x-intercepts. And then I move on from there. So I'm use vertex form the rest of the way. From here, over 1 up 2, over 2 up 8, 2, 4, 6, 8, and reflect that. Over 3 up 18, which actually does fit right up there if I did my math right. And once again, I kind of really did vertex form with the a value. I got x-intercepts and y-intercepts and stuff, that's fine. The stretch factor of 2, though, I spent probably more. Well, I had to get factored form anyway, right? So I probably spent more time getting into factored form for probably useless information overall, besides what they wanted. Oh, my back. Okay, number 75. Can a quadratic function... Oh boy. Oh, my neck. Can a quadratic function with exactly one real 0 be written in intercept form? Explain. I covered this earlier. So, oh my gosh. Chiropractor, let's go. Can a quadratic function with exactly one real 0 be written in intercept form? Yes. Keep this in mind. So, first of all, yes. Now, one real 0 means it hits at the vertex and goes back up like that. Okay? So, if this is P, then this is x minus P times x minus P. It's x minus P squared. That's what makes it a quadratic. I'm just going to write that. That's my explanation. The vertex is the x-axis, the x-intercept. That's where I said that they'd have you do something. They asked me to write, though. Fine. The vertex would have to be the x-intercept, which means it has a repeated root of, say, P in this case. Therefore, you square it. So vertex, okay, well, listen, intercept form, I guess, if I write it as x minus P squared, I'm going to then kind of expand that, not by, like, standard form, but just write it as, I'm not going to use another arrow, x minus P times x minus P. It's the same thing twice, right? It's a repeated root, and that's kind of what we'd want to get off of that. That'll work. All right, number 76. Your friend claims that any quadratic function can be written in standard form and in vertex form. Is your friend correct? Explain. Yeah. Yes. I don't know how to explain that. Yes. Once you have vertex form, okay, how about this? Yes, every quadratic has a vertex, and you can always expand it into standard form. I don't know if what they're saying is that if you have one, you can always convert to the other, if that's what they're asking, or if they're asking more of like, can you have both forms? Of course you can have both forms. If you are in standard form, use negative b over 2a, etc. to get into vertex form. The question is just, can you get the answers? You know? But yeah, if you find the vertex and you can get the stretch factor and stuff, you're good. You can always do it. However, you will need to be given certain information on the graph. The vertex would be nice. 3 points on the graph would be nice. Those intercepts and stuff would be nice. But yeah, you can. Your friend's correct. Good friend. 4 more. Let k be a constant. Find the zeros of the function. F of x equals this in terms of k. All right, I have no idea what this looks like yet. We'll see. F of x equals k x squared minus k squared x minus 2k cubed. Okay, don't treat k as a variable yet, really, like that. We want to really treat x as the variable. This is the x squared term, the x term, and the constant, stuff like that. Now, I see k as a common factor. I really want to deal with that to start with. So let's factor k out. I don't know if this will help me. It totally will. X squared minus kx minus 2k squared. And remember, this is a 1k, if that helps you. So we need to find two numbers that add to negative 1k and multiply to negative 2k squared, if that makes sense. Really, all I'm thinking about, I don't want to think about the k's so much. I know k's will be in the answer. So it's basically like this. It's going to be k times some sort of x and x here, and these answers will have k's in them. I just need to have numbers that multiply to negative 2 and add to negative 1. That's negative 2 and positive 1. So like that. X minus 2k times x plus 1k, or x plus k, right? So that's my factorization. That's how that thing will work. K is a common factor. K is not a variable. K is not a solution to this. It is just a number that represents something. X is my variables. This is where zero product property is used. You find the zeros. Your zeros are if x minus 2k equals 0, x equals 2k. And if x plus k equals 0, x equals negative k. So those are your two zeros for that. That's the answer. A little fun, a little creative. Number 78, sketch the graph of each function. Explain your procedure. Oh, boy. I mean, I know how to do it. I just don't know what they're going to, like, I'm trying to, this is more of an IM3 thing. F of x equals x squared minus 1 times x squared minus 4. Okay, for starters, yeah, I don't know how much you're supposed to know about this, how much you're not supposed to know about this. For starters, I want to let you guys know that remember when you multiply the last two things together, that can give you the y-intercept, so negative, and anything on the outside, but negative 1 times negative 4 gives you a y-intercept of 4. That'll be helpful when it comes to coming up with other things. Next thing is, these are differences of two squares. I can factor these, x minus 1 times x plus 1, x minus 2 times x plus 2. Like I said, this is very much an IM3 concept. I'm going to let you know about that right now. Your zeros, your x-intercepts, are 1, negative 1, 2, negative 2. Now, when it comes to graphing this, guys, I'm not going to use one of those tall graph things because I'm not going to get very specific points outside of this, and that's probably where I want to stick with it right now. I just want to say that, we're going to hit, 1 and 2 and negative 1 and negative 2 on this graph. It's going to cross through, okay? So it's going to hit these guys. On top of that, no pun intended, on top of that, it's going to hit 4, 0, 4 right here. That's the y-intercept. So here's the thing. Parabolas, U-shapes, they bounce back up, right? This is an x to the 4th graph. Notice this. X squared times x squared is x to the 4th. It's also an even function, an even degree function, which means it's going to start and finish up or start and finish down. I'm probably speaking more than you'll be able to know here. Bottom line is, it's a positive, right? It's a positive 1 times your a value is 1. This is going to start and finish up. We got to hit all these points and that one crossing through these. How's that going to happen? I can start from here, go through. It's going to come back up at some point, come and hit this guy. And it's going to come back down and hit this guy here and come back up and through like that. There's actually going to be a lot more symmetry on this than I drew, but that's a version of that graph. I'm not going to explain. I'm not going to write more as far as an explanation, but that's kind of what I went off of. Just I said them. I said I found my x-intercepts. I found my y-intercept. It's an x to the 4th graph. X to the 4th graph, which means it'll have this nature of starting and finishing in the same direction. Because when I raise negatives to an even power, it still turns positive. There are a lot of jumps in between, and this is what bigger polynomials do. Again, IM3. But hey, we're on the big problems, right? Part B, we have g of x equals x squared minus 1 times x squared minus 4. So it's the same thing, only, there's a x in front. It's the same thing, only with an x in front now, and it's going to change some things. For starters, the x-intercept's different. Because you know when I said, oh, you just multiply these things? Well, you have to be careful because -1 times -4 is 4 times x is 4x. We don't have a constant here. The y-intercept for this is 0. You don't believe me? When I factor this, or it's already factored, 0 is going to be your x-intercept as well. So it's totally going to happen. -1 plus 1, -2 plus 2, right? There are 5 x-intercepts this time. You have x-intercepts of 0, that's one of them. 1, -1, 2, -2. So this time with this graph, we're going to be crossing that 5 times. The y-intercept is the x-intercept of 0, right? So we're going to have 1, 2, -1, -2. Not very well drawn. We're going to hit these points, boom, boom, and 0, and boom, and boom. Now this is going to hit 5 times. And here's the thing. It's an x to the 5th function. It's an x to the 5th graph, which means this thing will start in one direction and finish the other direction, kind of like this. The a value is 1. It's positive. That means we have to finish upward. If I have to finish upward like that, which is true of the other one, if I have to finish upward, I'm going to be kind of crossing through like this. This isn't exactly how it's going to look. This is just a randomized version of it. But it would have to go down and through like that. Just all those coming through like that. Okay? Maybe not exactly the same heights. I have no idea what heights they're going to be. The symmetry is a little bit different in this case. But that's what it's got to do. That's what it's got to do. That's my explanation. All right, 2 more questions. Close to one of the longest videos on record. Write 2 quadratic functions whose graph intersects at the given points. Explain your reasoning. So the first one, listen, they don't say standard form. So through -4, 0, and 2, 0. Okay, well, given those whose graphs intersect there, they said quadratic, right? 2 quadratic functions. So you just choose different a values. We have y equals a times x plus 4 times x minus 2. I don't want to explain. You just change your a value. So this is going to be, I can do 2, sure, and I can do -5. Those both still cross through there. These numbers in front don't change your x-intercepts, right? They are just stretch factors. They stretch, reflect, those kinds of things. They flip over. That's the stretch. They stretch, compress, reflect, but they don't change the nature of your thing, right? So those are 2 of them. 80, we can probably do close to the same thing. Actually, maybe not so much. This goes through 3, 6 and 7, 6. This one's a little trickier. This one's a little trickier because these are 2 points. You know, we kind of want to use a graph for this one here. I'm going to borrow one of these bigger graphs like this. 3, 6, and 7, 6. You know, these are not x-intercepts. So, you know, this can cross through and do like whatever, but we're not really sure where it hits yet. What we do know is the vertex has to be in the middle. So when I write these functions, I can choose a vertex. It can be anywhere on x equals 5. Oh, you know, then I guess that's not that tricky, but I still got to find my a value if I do it. But I got to find a vertex of when x equals 5, right? So my h will be 5, like that. So I can use vertex form. They don't tell me what form. I can use vertex form and choose one of these xy's to do it, right? I can choose an a value along the way, but I need to get the k that associates with that a. It needs to be specific with the a that I choose. Or I can use a k value and be specific with the a that I... Did I say that? I can use a k value and be specific in that one and finding the a that I choose. Let's do that. Let's make up a if k equals... How about if k equals... Let's see. I want to make good numbers. That'll be a good number and that'll be a good number there. So if k equals 2... Then, you know, so keep in mind what we're using is this. Whoa. What we're using is we're using y equals a times x minus h quantity squared plus k. I have an h value of 5. And I'll use a plus 2 here. I'm going to substitute in x, y. I'll use 3, 6. I'll use 3, 6. So 6 equals a times 3 minus 5 squared plus 2. If I subtract 2 from both sides, I get 4. 3 minus 5 is -2. We'll get -2 squared times a. That looks weird. Oh, boy. I'll write it how it was written so you're not confused. A times -2 squared. -2 squared is 4, so 4 equals 4a, and a equals 1. So this equation could be y equals 1 times x minus 5 quantity squared plus 2. There's one of them. I'm making them up, right? Excuse me. Last one. If k equaled negative 2 right here, and I'll use the other point. I'll use 7, 6 this time. We'll have y equals a times x minus 5 quantity squared minus 2. So I'm going to use 7 for x, 6 for y. So we'll have 6 equals a times 7 minus 5 quantity squared minus 2. I have to add 2 to both sides of this thing. I'll get 8. This is a times 2 squared. 2 squared is still 4, just like negative 2 squared was. This is 4a, so a equals 2. This equation will be y equals positive 2 times x minus 5 quantity squared minus 2, because that's what I had there. They just said write a quadratic equation. They didn't say in what kind of things. Explain my reasoning. I'm sorry, this is number 80. It's because I chose some things based off the vertex. The vertex is 5. I wanted to choose a k value for that and get an a. I could have chosen a value and gotten a k. I just chose not to. And that was that. All right, guys, that is it. That ought to do it for this one. 2 hours, 40 minutes. This is Mr. Robinson. Thank you so much for watching. I hope that this was very helpful. Next will come section 2.6. I forget what it's on. I think focus and stuff like that. Generally do that in IM3, but maybe they'll do a little bit less of it here. So thanks, guys. Check the description section down below. If you need anything else, again, leave a comment. Let me know if you have any questions, and take care. I will see you in the next one.